afternoon, everyone. My name is Connor Eller. I'm Captain of the Leeson Fire Department. Today we'll be going over thermal imaging cameras in the fire service. So introduction-wise, first, my name's Connor Eller. Like I said, Captain Paramedic. I've been here for 13 years. Currently assigned to Pumper 5C. I've been an instructor for the fire department for a number of years, teaching nozzle and hose line operations. Forcible entry repeatedly through our academy, search and rescue class in our academy, ventilation courses, both vertical, horizontal, and off the trucks, and now I'm working on thermal imaging camera applications. A little bit of background about the qualifications. I've got my Fire Instructor 1. This is completing my Fire Instructor 2 program. Fire Officer 2 qualified. I've been to the NFA for the Command Control Company Operations level training course, and hope to continue training every year and add more to that list. So, going around the room, we had one student step out briefly. I'm sure he'll be back. But we're going to do some student introductions. So, we'll talk about who you are, how long you've been in the fire service, what your experience is with thermal imaging cameras, and what you expect to get out of this class. So, starting up here, please introduce yourself.
I am Chase Reisinger. Been in the fire service less than 2 years. I have little to no experience with thermal imaging cameras outside of what we do as a company. And I expect to become a expert in thermal imagers by the end of this class.
Expert level. It's a good expectation. Hopefully we can achieve it. In the back.
Justin Yeager. I've been here at the Leeson Fire Department for 7 years. As far as experience goes, I'd say mostly in training is when I've used the thermals. So not a bunch of real life experience, but hopefully after this class I'll get a better understanding of our takes that we have in thermal imaging cameras. So
I'm Alex. I've been in the fire service just over a year. I don't have much practical experience with cameras, and I want to learn all the capabilities and functions that they have.
All right. I think we'll be waiting a while if we wait for our last student. So we'll keep on moving. All right, so a little bit of housekeeping. We had to change locations, so we are now at location station 7. The exits are located there and right here. In case of emergency, please file in orderly fashion through those exits and get out of the structure. Restrooms are located in multiple locations throughout the station. We're on the training room side, so there's one just outside this door to your right. It is a unisex restroom. And across the bay and off to your right, there's a single door entrance that leads to both a male locker room and a female locker room. For nutrition needs, we've conducted this class after lunch. If you do require a snack, there is a kitchen located across the hallway and down to the west. Crews are on duty today, so please be cognizant of them and be aware that you may be interrupting some of their activities. Beyond that, if anyone's having issues with hydration, we do have a water filling station right there. There should be a bottle of water at each student's location. And if you're concerned about dehydration, we do have electrolyte drops located over there on the wall. Those are drip drops provided by the training division. We will be taking breaks throughout this course. Studies have shown that students sitting through continuous learning don't actually capture as much as they would if they take a break. So we will take a 10-minute break roughly every 50 minutes through this lecture. Our practical location will be here at the training center. Obviously the lobby is right outside of this doorway. We'll be working through both this attached tower to the station as well as the tower located outside. For equipment, we're all wearing Class D uniforms. That's what we need to be wearing today. Hard-soled steel-toed shoes. And when we go out and do the practical applications portion, we will utilize a combination of both the Class D uniform and your issued bunker gear by the department. All right, so a little bit about this course structure. This is going to be approximately 3 hours, including the breaks. This is broken up into a practical application and a lecture application. So obviously during the lecture, audience engagement is preferred. It makes the class a little bit more entertaining, and I find that students get a lot more out of it when they ask questions as they come up. So if you have a question, please don't hesitate or hold till the end. You can ask as we're going. If you're wondering about something, chances are another student may be wondering about that as well. So asking quickly is welcome. We will be doing some brief knowledge checks. And when we do take our breaks, please try to be prompt. I'll establish what time we're supposed to return to the classroom when we go on that break. For the practical portion, it'll be roughly an hour. It will be, like I said, located out here at the training center. We'll be out on this fire ground, and then part of it will be working through the apparatus bay into this side. You will each have to demonstrate your abilities to meet the course objectives, which we'll be going over shortly. Full PPE will be utilized in accordance with the Lee Summit Fire Department SOG number 4, which pertains to safety. At the end of this course today, following the practical applications, there will be a written examination, and we will conduct some course evaluations. Any questions so far? None? All right, we'll keep moving. So, safety brief. Obviously, safety is the number one priority for this organization. As first responders, we have to be safe in order to help others get safe. So full PPE, like I said, will be utilized on the training grounds. We'll be working with one instructor and one student in a 1-to-1 ratio for these evaluations. Hazards that are available, blood clots, because you'll be sitting for a while. That's kind of a joke, but also kind of serious. Please stay hydrated. Low light concerns, so we will be operating in low light or low visibility conditions utilizing these thermal imaging cameras, so please take your time, be cognizant and ensure that you have adequate footing and that your movements are smooth and slow. Slow is smooth and smooth is fast, right? Dehydration, we need to drink water, so Mr. Reisinger, if you need another water, there's another one here, and there's also a refrigerator located in the back and a fill station over there with that water fountain. And then battery failures. There is always a chance the battery on our cameras will fail while we're conducting an application. So in the event that happens, we will remove ourselves from that environment slowly and ensure that we're doing our due diligence to not get hurt. And of course, there's real world hazards. There's always uneven surfaces, things that you can trip on, things you can run into. So like I said, smooth, cognizant movements will be really helpful. All right. So some of the standards we'll be referencing today in this course fall under both the SOGs and the NFPA. So like I said a minute ago, we're going to be referencing SOG 4 for safety, as well as Lee Summit Fire SOG number 7, which covers Rapid Intervention Crew, also known as RIC. Please be aware that it is RIC, not RIC Crew or RIC Team. That's redundant. NFPA standards that we'll be referencing NFPA 1801. This standard is the standard on thermal imagers for use in the fire service. It sets forth the minimum requirements for these thermal imaging cameras, and they are used by fire departments focusing on usability, image quality, and the durability of the unit. 1408 references the standard for training fire service personnel in the operation, care, use, and maintenance of thermal imagers. And it provides guidance to us for training fire service personnel on the effective use of thermal imagers. These two are important because they are governing body issued, and it outlines how we should be conducting ourselves beyond just what's written into SOGs, which does not necessarily cover all of these applications, which is why we're going to reference them. We'll also be looking at NFPA 70B as in Bravo. This standard is for the electrical equipment maintenance and outlines requirements for electrical equipment like thermal imaging cameras, among others, including the use of thermography for identifying potential issues, as well as 70E as in Echo. The standard is for electrical safety in the workplace and addresses safety, including the use of PPE for those thermographers, people using thermal imaging cameras, to determine thermal layers and considerations for arc flash protection. So why should you take this class? Well, Lee Summit, as we all know in this room, is an ever-growing city with aging infrastructure. We serve over 100,000 citizens, including our contract agency. Last reference estimates 106,000, and we cover 77 square miles. We average roughly 35 working structure fires per year over the last 10 years. And we have large expanses of farmland and woodland, as you may have seen as you came into the station. There's plenty of open area for different types of fires. We have multiple different types of occupancies, ranging from small single families to large single families. We have numerous different types of apartments that go from the small brick style with 1 or 2 floors, all the way up to the large multi-use ones located in our downtown district. We also have a lot of commercial occupancies with manufacturing, educational facilities, and others. And as we continue to progress with technology and equipments, fires are burning hotter and faster. That's due in large part to the materials that we utilize for them, as well as the materials that fill these structures. So hydrocarbons become very important to be considered of, because these fires no longer burn slow and give you time to get in there and make effective action. You really have to be on your A game to try to get in there. We are making rescues at the Lee Summit Fire Department. We never know when our number is going to be called. Beyond just training for physical fitness and ability, we got to train in all the other aspects of the job. You never know when it's going to be your turn to be the one making that rescue. And when it comes down to a matter of seconds, that's when we need to be efficient with our equipment. So every seat in the fire department in operations has a thermal imaging camera. There are different types of cameras that we have throughout our agency, which we'll cover today. Are you able to use them effectively? This question is rhetorical, but it's something that I want you to consider as we go through this course. Thinking about when we came in and talked about in student introductions. Are you comfortable with thermals? Do you have a lot of experience? Is it based solely on training? When was your last training? That's, like I said, a rhetorical question, but it's kind of the purpose for this course today. So, when was your last thermal imaging training? Alex in the back, have you had thermal imaging training in the last year? Yep. Mr. Reisinger? Good. Have any of you ever taken a thermal imaging specific course? All right. Well, let's talk about some course objectives. Objective number 1, I try not to read off the slides entirely, but for these I will because it does matter. The Lee Summit Fire Department student, given the thermal imaging cameras in service at present, will accurately identify the different cameras and the components of in-service cameras. This covers the remember component as far as learning goes. We talk about all of these different objectives. We're going to cover different styles of learning to try to meet all of those. The audience is going to be you guys, the Lee Summit Fire students in this course. The condition will be that your students are provided 3 different cameras that are currently in service at this agency. They're on the table in the front here, which we'll be going through here shortly. The behavior is what you're going to be doing, so you shall demonstrate proficiency in the determination of the components of these devices, meaning we're going to go over these cameras and you should be able to effectively identify all of the major components within them. The degree or the standard to which they're being graded on this objective is 100% accuracy. Objective number 2, understand the capabilities of these cameras. In this objective, the LSFD student, given the thermal imaging cameras in service at present, will accurately identify and differentiate the capabilities of in-service cameras. This demonstrates your ability to understand the material that we're covering today, to process it. Obviously the audience is you, the students. The condition is that you're provided 3 different cameras that are in service and must be able to differentiate between their capabilities. Behavior, you'll demonstrate proficiency in determination of the correct camera for different fire service applications. And the degree is 100% accuracy based on display or application. Objective number 3, use of cameras in fireground activities. The LSFD student, given the thermal imaging cameras in service at present, will demonstrate understanding and application of thermal imaging cameras during fireground activities. Audience is you, the students. The condition is that the students are provided 3 different cameras and must be able to proficiently utilize them in patterns of survey, search, and fire behavior or location. The behavior, you shall demonstrate proficiency in locating a fire, a victim, and identifying the fire. The degree of accuracy, 100% accuracy based on display or application of said technique. Objective number 4. Use of camera and determination of fire behavior and convection characteristics. The LSFD student, given the thermal imaging cameras in service at present, will demonstrate understanding and application of the thermal imaging camera with regards to fire dynamics. This is your application of the concepts we're going to cover today. As always, you are the audience. Condition will be students are provided with 3 different cameras and must be able to describe the fire scene and its components. The behavior. Students shall demonstrate the ability to isolate the seat of the fire, the thermal layer, the exhaust flow, and radiant heat displayed on screen. And degree of accuracy is 100% in identification of the flow path types. And finally, objective number 5. Use of camera in large area search applications. The LSFD student, given the thermal imaging cameras in service at present, will demonstrate understanding and application of thermal imaging cameras during large area search activities. You are the audience, and you students will be provided 3 different cameras that are in service and must correctly identify which one to utilize for this application. Behavior, the student shall demonstrate proficiency in sweeping, organization, and recognition of thermal differentiators in large area search. This will be tested to a degree of 100% accuracy based on display or application. Are there any questions over the objectives we're going to cover today? No? Okay. So let's talk about some of the history. Most of these classes do really well when they give you the history behind why we do something or why we use something. This is no different. So, in 1947, the military began using infrared scanners. These scanners were very limited in their capabilities. They mostly functioned as a pyrometer, meaning they could see a fire or heat produced by a fire, but they gave no indication on its size or its temperature. Basically, it showed you that there was one and kind of where it is, but it didn't tell you what kind of fire it was, what it involved, how big it was, or any of the pertinent stuff that we see today in thermal imaging cameras. The military continued to pioneer these cameras, and in the 1970s, wildland firefighting picked this up as well. These pyrometers assisted the wildland firefighters in California specifically to be able to see the size of a fire, particularly through the smoke plumes as they ran in the undergrowth. This is really pertinent because a lot of the terrain in which they have wildfires is very, very jagged, very rugged, and so it's very difficult to see where the actual fire is when you have a large plume of smoke working up a canyon or a cut. Through that use, they continued to develop more of the different abilities within these cameras, and they slowly began to trickle into structural application. This was trailblazed once again by the military. This became more refined in maritime firefighting, or shipboard, as the maritime firefighting subgroup crews would often struggle to locate the fires in nearly airtight compartments. Working through ships, those are small containers anyway, and it's going to be very difficult to navigate, especially when there's smoke being pushed through. So they found a need and an ability with these thermals and continued to work on them. They were still very cumbersome in that application, large, heavy, expensive, very fragile, and there are a lot of limitations to those devices. They were not like the ones we have today, but they were continuing to progress from the 1947 pyrometer that was adopted. So in the late 80s and 90s, we saw a transition into what we know today as a thermal imaging camera. There were several maritime accidents, including the HMS Sheffield disaster, which is not scrolling down. Let me switch to my notes over here.
What is the first thermal imaging camera that you used?
The first one I used was a Bullard, and it was very similar to the 5200 that we had.
You didn't start with the ones for the wildland firefighting?
I did not. I have not been around quite as long as that. I know it's not popular. All right. We'll keep moving. Adapt and overcome. So the HMS Sheffield was a ship that had a very severe fire on it and caused a lot of injuries. It was in the late 80s. And following that, they began to see dissemination of thermal imaging cameras into the American Fire Service. So, once the 90s hit, ticks began to show up. They started in Seattle and portions of California, obviously where they were close to the maritime access. And the need was highlighted because there was a potential to save a lot more civilian lives and ease the process or expedite it for fire suppression. They were often very large and heavy, and they were slow improvements over old technology, but it was still steady progress. They typically were mounted to helmets, still quite expensive, and the imaging produced was not compelling enough to adopt throughout the nation. So it really became dependent on the fire department to invest in this technology. Those that did invest helped spur more of the technological advancements that we see today and what we know for ticks. And a FLIR, which is thermal imaging, was the first tick that was actually adopted for fire service use. Let's back up just a little here. So the first recorded civilian save with a thermal imaging camera occurred from the Putney gas explosion. When we talked about the 80s and 90s being when they were being trailblazed, this occurred in London. So the gas explosion was pretty devastating in the Newnham House area, which is a 3-story block of luxury flats in South London. It killed 8 and injured dozens, and it was caused by methane that was leaking from a cracked cast iron gas main that became under stress due to structural settlement and heavy traffic. It was reportedly equivalent to a 50-pound bomb, and it caused damages estimated in excess of 250 million pounds at that time. And referencing Seattle, they were credited as one of the first major departments to acquire a TIC in 1997. When we said they were expensive, they were $16,000 in 1997. That would have bought you a pretty nice loaded pickup truck at the same time, if you want to keep it referenced for today's spending. All right, so let's talk about the Fire Act. FEMA Fire Act is the Firefighter Investment and Response Enhancement Act, and it came around in 2001, endowing $100 million to U.S. fire service organizations. This was huge because it allowed a lot of agencies to jump into and buy thermal imaging cameras, their first ones for many departments. The purpose behind this was to bolster the capabilities of our fire service as a whole. This did occur prior to 9/11, and it just happened to be part of many changes that spurred throughout that year and the year following. So what we then saw was a prolific growth in popularity. Because these cameras started hitting the ground everywhere, people began to see their uses in real application. So what they then ran into was the high cost for repair and maintenance. It became a very common budget item. These cameras were often assigned to specialized units in these agencies due to the cost, and those were typically heavy rescues, truck companies, or dedicated RIP crews. The TIC became a common budget request item, not only because it aided with civilians, but also RIC. The following Charleston 9, a thermal imaging camera was a recommendation for assignment to each engine and ladder company in their organization. And if you're not familiar, you can spend some time on the break to look that up. But it was a tragedy that 9 Charleston firefighters died in a furniture store fire. With thermal imaging cameras, it's possible, as always, we can speculate that they may have been able to find an exit and exit safely. Unfortunately, they did not. So, the innovations and revolutions in technology led to a size and weight decrease, which was very significant because they became very cumbersome very quickly when they're mounted to your helmet. So moving to the hand and getting lighter and smaller means that guys are more capable and can move through structures much more simply. Many of the companies that we associate with thermal imaging cameras also began to emerge following the Fire Act. That's MSA, FLIR, 3M, Scott, Bullards, etc. In fact, we see Seek now in the forefront. They weren't around at that time. Any questions on the history? All right. It's fire behavior. Obviously, everyone in this room has got their firefighter 1 and 2, and is probably pretty familiar with this, but it never hurts to refresh information. When I went through Fire 1 and 2, we only had a fire triangle. Now it's a tetrahedron. And the addition of that was chemical chain reaction added to the triangle, which was fuel, oxygen, and heat. In order to have a fire, all of these components must be present. So let's talk about some of the stages of the fire. Who remembers what the stages of a fire are? There's incipient, right? Which is the initiation of a fire. And then what?
Growth.
Okay. What else? Fully involved and decay. Yep. All right. So, with this fire tetrahedron, in order for a fire to reach the incipient stage, the fuel provided must be burning. The heat raises that fuel to its ignition temperature, whatever that source may be, and then oxygen supports the combustion process. This chemical chain reaction sustains the fire because once it starts, it continues until there is a limitation of one of those 3 components, and allows these elements to interact continuously. Like I said, removal of any of these components or diminishing the amount of it will cause the fire to die down and or extinguish. The fire tetrahedron simply builds on the simpler fire triangle and emphasizes the chain reaction's role in maintaining combustion. So, talking about fuels, what are some really common fuels that we encounter in residential structure fires?
Wood,
Wood,
couches,
Synthetics.
synthetics, hydrocarbons. Hydrocarbons are most commonly encountered fuel. Does anybody know how to define that?
no.
Basically, it's manufactured material. So, combustibles like furniture, fabric, fabrics and paper, those are simple, we understand those. But the hydrocarbon references the oil layering in furniture, the paintings on the wall, all of the plastics and other materials that are synthetic that we have in our homes or businesses. Those burn pretty readily. They often burn hot, and they off-gas a lot of extra toxins. Oxygen, pretty self-explanatory. That's the air that we're in. Does anybody know what concentration of oxygen is present in room air?
40.9.
There we go. Fantastic. Somebody must be a paramedic in this room. And heat, well, there's many types of heat sources. You have electrical issues, direct flame, radiant heat. We'll get into some of those here in a little bit. How do we typically remove that heat?
Water.
Water on the fire. Put water on fire and it goes away. Or ventilation. Everybody doing okay? Anybody need a break?
Doing alright.
Doing all right. Okay. Oops. Yes, it. All right. Let's talk about fire dynamics. So, anybody here 1403 instructor? Mr. Yeager, you are? What comes to mind when you hear the words fire dynamics?
How the fire is growing, or I guess, say you get called to a structure fire with the smoke, kind of reading smoke.
Okay.
And then if the fire is growing, what stage of the fire it's in. So.
Dynamics really just covers the existence of fire, the different types of conditions that we can adjust to affect it, how it affects itself as it burns, what it does. So referring here to the scientific principles governing how fires ignite, grow, spread, and are driven by heat transfer, fuel characteristics, and environmental conditions. In residential fires, we have dynamics shaped by confined spaces. Houses are typically built with several bedrooms, living rooms, and other things, but as you get to larger and larger homes, the layouts may change, and that can drive the dynamics of the fire and how it spreads and exists pretty readily. We have diverse fuels now, like we talked about a few minutes ago, woods versus hydrocarbons, synthetics, and limited ventilation. Houses are made to be airtight now. That's one of the benefits of having them. You get a lower power bill, but it also entrains a lot of heat and keeps everything trapped inside. Obviously, fires typically start small, barring some kind of explosion or arson. So heat transfer is typically initiated with conduction going through walls and surfaces. We also have convection, which is the rising hot gases and smoke plumes as they go throughout a structure. And radiation, which is direct heat transfer through the air to nearby objects. Ventilation is incredibly important with fires. As a 1403 instructor, you probably attest to that. It controls how the fire grows or may die out. So an open door can rapidly intensify the fire by supplying oxygen. That alters its growth pattern. I know in previous times when we've gone through the burn room, we can illustrate in a small 10 by 10 room that opening a door for about a second can cause a direct temperature increase in a 2-pallet fire of 100 degrees just by entraining fresh air. Now there are other components that affect that depending on how much steam's in the room. But it's very easy to rapidly expand that fire simply by ventilating without coordination, which can be a huge safety concern.
I think one of our last fires was a basement fire, kind of like hoarding conditions, but the whole couch was on, basically it burnt up, but it put itself out because it was limited on ventilation.
Then limited. That's where the house being buttoned up and well sealed can play in our favor, especially with rooms. That also leads to that close before you doze component. Is everybody familiar with that? Yeah. And commercial fires, they are a little bit different than residential's for a number of reasons. The fire dynamics can differ in commercial fires due to larger spaces. We think of the big box stores, manufacturing facilities, even strip malls, they can be larger. There's typically a higher fire load in these occupancies, and they often feature different structural components. Most residentials are what class? And Lisa, we have classes 1 through 5 for building construction. Does anybody remember which class the typical house is here?
3? 2?
Typically class 5. Wood frame. Some people with a lot of financial capability can build 2s that are fire resistant. Class 1 is typically only seen in different buildings like hospitals where they need to be effectively fireproof, and it causes a lot of money to go into that. So some of the layouts as well, besides just having steel frames with all of their structural components, is they have open layouts. Manufacturing facilities can allow a lot of smoke travel really quickly because they don't have the walls and partitions that we do in residences. Think about living rooms, kitchens, and dining rooms being open. Bedrooms are not, closets are not, office spaces are not. Garages are separated. So we have the ability to confine the smoke. In a lot of commercial fires, that's not the case. So heat transfer will occur on a grander scale. Radiation will ignite distant combustibles because there is nothing keeping everything piled in there. And the convection drives the smoke across vast areas. A building will fill with a lot of smoke very quickly, especially if there's no way for it to exit and it begins to bank down. Commercial fires often reach higher temperatures and involve many complex fuel mixtures, which increases the risk of backdraft or collapse within that structure and also makes it very difficult. Kind of an aside to this, modern homes with synthetic materials will burn hotter and faster. They can now reach up to 1,000 degrees in a matter of minutes, just on a basic room and contents fire, which will rapidly spread the smoke because the heat pushes it. We're talking about fire dynamics and reading the smoke. As it gets pushed out further and further, the heat transfer occurs. Because these materials ignite more readily, it continues to proliferate across the residence. All right, so modern thermal imaging cameras. Trying to read that back there because it's not showing up over here. Newer ticks are smaller in size. We referenced how big and cumbersome the ones were that were aboard the maritime applications and even into the 90s where they were helmet mounted. Now they're almost exclusively handheld devices. There is a company out there that was at FDIC just last week demonstrating a helmet mounted tick that functions similar to a flip down visor. That's next on the horizon. They're often built with rechargeable batteries and they get mounted in the cabs of trucks or in compartments. We began using them for firefighting operations, search operations, large area search operations, and on the training ground to build confidence with the tool. As they have continually progressed, we've been able to make them, or manufacturers I should say, have been able to make them less expensive, which leads to a lot of the apparatus having at least one thermal imaging camera. Here at Summit, we're blessed to have one in each seat whenever they are in service. So, give me 1 second here. A fun fact or an aside to modern ticks proliferating through the fire service, they really spread quickly because the word spread that they could be used to find lost animals trapped inside of structure fires and walls specifically. Looking for animals that get trapped inside of a wall, you can use a thermal imaging camera depending on how thick the sheetrock was to locate where it is. We are 35 minutes in. Okay, we'll keep moving here. Let's talk about some of the science stuff. This is kind of my domain. I love the geeky things. Modern thermal imaging cameras function off of infrared technology that detects and measures the infrared energy of objects the camera is pointed towards. They have a lens that receives it, comes through that lens into the sensor, which allows the information to go through to the processor, and then comes into your display. The memory obviously helps apply how it looks on the screen. These cameras convert that energy, that infrared energy that they're measuring, into data, which then goes to an electronic display on your screen, showing the surface temperature of the object you're pointing at. Essentially, they see the heat signature of something rather than the visible image itself. So when it produces an image, it's producing the heat signature, not what we see with our eyes. This allows us to use the cameras to see through visual obstructions like smoke or low light levels. They still operate perfectly fine because they don't have the rosin cone style eyeballs that we do. They have a computer. Oops.
Is that how every tick is built, basically?
Yep, that's the same technology throughout. If you look at these different MSAs in the seat, there's a lens on the front, and that's how they all operate. Bowler's the same way, Scott's side, all of them. So the camera itself operates with a principle of emissivity. Has anybody ever heard of that word?
No.
Emissivity is the property of a surface and its ability to emit thermal radiation, infrared energy, compared to a known emitter at the same temperature. It's gonna get kind of sciencey here for a minute. Emissivity is measured on a scale of 0 to 1, and 0 is equivalent to a perfect reflector. Think of like a body of glass, a window, things like that. When we use a thermal imaging camera, we see a reflection on that. That surface's emissivity is very low. And 1 would be the level of a perfect emitter, and that would be something like a body on the ground, a black body of material. The more radioactive, or reflective that a surface is, the poorer the measurement will be, which again is why glass, windows, all those don't allow us to see any thermal registry on there. So can a tick see through glass? What do you think, Alex?
Not really.
No, they can't really. Ticks can see through the clear air and the smoke in front of that glass, but because of its emissivity being basically 0, that infrared energy is not being projected through it, and so it cannot see it. In fact, you see the frame around it. It'll show reflections, so when we use thermal and we look at a window, we see reflections of us holding that camera, right? Older glass, like the early 1900s, which is the single pane, it'll heat up, and it'll be more than double or triple pane, like now. They will illuminate colors on the single pane because they heat up. The double and triple will create insulation, but also provide more panels behind to entrap that and keep it to where you cannot see through it. So that color will be shown on high sensitivity, which we'll cover more later. As far as frames and walls go, the frames and walls in a fire will illuminate heat. They kind of illuminate what you have as far as it impacts that structure. So an example being a fire, obviously the frame will continue to heat up, but the drywall will probably be hotter than it. However, if you're looking at a cold wall, you'll be able to see frame behind drywall because it may be impacted to a directly outside wall. A great example of this, if we took a camera on a cold day to one of the bedrooms in this station along the north wall, you will be able to see with thermal imaging camera the metal studs behind the drywall because their direct contact and convection of cold make them colder and they show through. But in a fire application, the frames and walls around it will illuminate with heat, especially if there's a good seal. The smoke will be getting charged and it'll start pushing through, which causes a heat transfer just from direct contact. So we talked about how they can't see through glass. Water would be another great example of a reflector. They can't really see through water. They are not intrinsically safe. What does that mean? Does anybody remember intrinsically safe?
Spark a little bit.
Can spark? When does that matter?
There's flammable gas.
Right. So hazmat conditions, fuel spills, things like that. What about things that happen for technical rescue? Is there an application for that?
Confined space.
Confined space, below grade, stuff like that, where we don't know what's down there. Taking a thermal imaging camera, which is not intrinsically safe, can put yourself in an immediate risk. Clouds of methane, sewer gas, whatever, down there. Again, flammables. High quality insulation in structures. We mentioned earlier how the windows and all the seals are making them airtight. We also have better insulation. How does that conceal a temperature? If a room's really well insulated and there's a fire behind that wall, we may not be able to see simply by looking. We may have perfect conditions in here. So as long as you don't bypass that door, you'll be able to find it. But you may not see anything trying to look through the wall and looking for direct heat. Flames will obscure objects. You can't see through them. So as a 1403 instructor, you've probably seen that on burn props. You obviously know the shape of the prop that the fire is built in, but when you're looking at the fire itself, that's all the camera sees, right? Because it is emitting really strong infrared signals. One of the other limitations for thermal imaging cameras, user error. So there's a lot of this, which I think is part of the reason why you guys are in this class, that we just don't know what we don't know. We as a fire service don't necessarily train as readily on this stuff because it's really sciencey and it's not hose flow. but it's really important. When you scan too quickly, that can cause a lot of issues within that processor. We become reliant on the numbers. Thermal imaging cameras should never be used as a pyrometer, trying to tell the temperature. You shouldn't be able to see the temperature of a room with a camera. You want to see what's in there. Trying to get a direct temperature on the surface of an object is going to be incredibly inaccurate. In fact, the best thermal imaging cameras out there still come directly from the factory with a plus or minus 18 degree swing on their calibration. So that's going to be pretty inaccurate. Whiteout, so that can be color saturation within an entire room where everything is the same temperature. In a fire, that's not extremely likely for us to be around, but that can have a lot of application in large area search, cold conditions, places that aren't sealed well. And then maintenance, as with anything, we gotta take care of our stuff. If we don't, it's gonna start to fail us. It'll break faster, and it won't work when we need it. Dirty lenses can be extremely problematic. It won't function properly if it can't see what it's doing. Steam can be pretty problematic as well. Not only because it can occlude the lens, but with enough of it, you can potentially get some behind the display screen, and that won't produce an image for you. Battery life, there's not a whole lot you can do about that other than following manufacturer's recommendations. We want to make sure that we're being diligent with charging, dispelling the charge when necessary, so read the manual. Every once in a while, it's not a bad thing to do. You guys think of any other limitations? Broken screens, yeah. Not caring for the equipment, dropping it. When it breaks, who usually breaks it?
Us.
No, it's the shift before. We
Yeah.
found it that way.
Yep.
Yeah, must have been B shift, right? Alright. We'll get through probably one or two more slides and we'll take a break. Do you need to use the restroom?
I do need to use the restroom.
Well, we can take a 10-minute break now. We'll just kind of push through some extras. So let's return to the classroom at 2:47, please. Display with my notes back there. We are still recording, by the way. Let's see if I can locate our other student who had to step out.
Medical emergency.
Proceed?
Legitimate, and we wouldn't know because we've been stuck.
Yeah, about 10 minutes still. Well, 9 now. If you want to walk around, stretch out, keep those blood clots moving.
Alright. I feel one coming on.
You do. That's not good. How's your day been so far?
Pretty good.
Yeah.
Day 1 of 3. Been pretty busy.
Makes the day go faster.
It does make the day go by pretty fast. What are you having for dinner?
I believe we are doing something with rice and stir-fry veggies and steak and shrimp. So some kind of stir-fry. Word on the street is the cook's gonna put it on the Blackstone and cook it all together, so we'll see how that goes.
Is the rice made already?
I'm aware.
I just
So-
heard that makes better rice.
Yeah, I've heard that if you do it at least 24 hours in advance and leave it out on like a baking sheet to dry out, it is. I don't typically eat fried rice too often.
We do.
If I'm buying General Tso's chicken, it's usually with the steamed rice.
Lo mein?
I do like those. Different noodles though. These to some technological difficulties, Mr. Reisinger's gonna move back here.
Gotcha.
The 2010 vision I once had is now 2015. I'm having a hard time catching my notes in the back. This is much better.
last time I filmed was this old man that fractured his femur. But he said his pain was still high, but he was kind of joking with me and stuff. Like, I was like, sign this white square. He's like, that's a rectangle.
There should be a water at your workstation if that's what you're getting.
What's that?
There should be a water out here at your workstation if you're grabbing one.
You like the door shut? Door shut?
Yes. Do you mind shutting that? Alright, so we will reconvene. Welcome to class. Mr. Hoyer, if you'd like to stand up and provide instruction, we did go around the room. So if you just tell us your name.
On the camera.
You can stand right there. Should be good.
James Hoyer.
How long you been here? Or in the fire service?
I'm in, at least I'm in a little over 3 years. I'm in the fire service about 6 years.
Do you have a lot of experience with thermal imaging cameras?
I wear one every day on shift.
Okay.
And then yeah, any fires, we bust them out.
You ever taken a thermal imaging specific course before?
No, I've not. This
And
will be
what
my first.
what do you expect to get out of this course today?
To have a better understanding of the thermal imaging camera
Fantastic.
and its functions.
Those all sound good. Well, you're jumping in after our first break. Mostly we've covered fire dynamics, fire behavior, and the history of thermal imaging cameras, as well as kind of how they work, discussing the lens. If you'd like on the next break, we can do an overview of that, or you can get with your compatriots and we can test their knowledge retention as they explain those things to you. We're going to pick up where we left off, moving forward into the tick ability. So, they do read temperatures, kind of, right? They read a temperature range. Like I said earlier, we cannot trust the number displayed on the screen because it comes from the factory, allowed to be plus or minus 18 degrees Fahrenheit in accuracy. It does provide us the ability to see temperatures in a color band, which is pretty helpful, right? That'll give you the most accurate range. At a certain point, hot is hot, so we want to be able to tell how hot it is. Big thing is knowing your mode selection. So most of these thermal imaging cameras operate off of different modes, and if we wander into the wrong one, it may cause a lot of problems. We'll discuss that in more detail as we progress along. Do you guys know that on the MSA 6000s we have a laser pointer? The gray and black thermal imaging cameras?
What would you use that for?
Well, in theory, you can use it to identify a surface plus or minus 18 degrees Fahrenheit accuracy. In application, it's limited by range to roughly 20 feet in front of you. Really, it's good for identifying a location. You can use it as an officer to say, hey, I want you to go ahead and pull ceiling right there. You could also just point and tell someone, hey, pull ceiling right there. It's an option. It's great to have. It's
Have
not
you
heavily
used it?
used. In training, not on fireground. Alright, so the cameras that Lee Summit Fire Department has. We have the MSA Evolution 5200. That is the one that we're all probably used to. If you've been here quite a while, this is what you originally had. It is this camera. Different ones have different stickers, some of them have a white background. We do have a couple of the 5000, which was the first iteration of this generation, still floating around. Not very common, I think they're isolated to Chiefs vehicles. We also have the MSA Evolution 6000 Plus. This is the one that hopefully we get to on our trucks, because this one works a lot better than that one. There are limitations to both, and in some aspects that one may be better. We'll discuss that further. We have the Seek Fire Pro 100. So this is the situational awareness thermal imaging camera that should be affixed to every air pack that is in service on our trucks, right? And then we have a fourth one. Alex, would you mind grabbing the sight mask from Pumper 5? Should be in the back seat. Have you guys all put hands on each of these before? No? Which one have you not messed with?
The side mask.
Fantastic. We're going to talk about that. We'll cover it in more detail as we progress into this. So he's going to grab that for us, hopefully. Let's talk a little bit about it now. All right.
When did we get side mask on Pumper 5?
These came in 2019, I believe.
They're like behind the seat, aren't they?
Yeah.
I wonder if they
Yes.
use very much.
They were initially, and we'll kind of discuss that. And hopefully Alex will be back quickly so we can start this video. I would hate for him to miss it.
I think their storage location tells us enough about it.
There could be some subtext involved there. While we're waiting, Austin, thinking of thermal imaging cameras off the top of your head, having not sat through the first part of this class, what are some limitations we can encounter with these?
Obviously, if you're in a high enough environment, that could affect the like durability of it.
Sure.
Melt. If it's battery life, sometimes is not the best.
Mhm.
The older ones, no matter how many times you charge them, and then conditions. I know, like, isn't it like if you point at like stainless steel?
Stainless it's a weird property. We discussed, so the thermal imaging cameras operate off of a principle called emissivity, which is reflection of infrared energy. That's scaled from 0 to 1 when you score its ability to be an emitter. And glass would be like a perfect 0, a perfect reflector. That's how you can have mirrors and window panes that reflect our image back to us in thermal. Whereas something that absorbs heat as a perfectly black surface would be something that's a 1. So think about putting a black t-shirt out in the middle of the summer outside and the sun beats down on it.
Couldn't find it.
Unable to locate. Okay, we'll try to find our next break so we can continue through this program. We can put hands on with it. In the meantime, I've got a short video to watch. Play.
So you have to go to that screen.
Might have it. Okay, I gotta find my cursor. There's 3 different screens it can be on.
There it was.
Aha. Alright.
When firefighters' objective is to go into a room and to rescue victims, in a smoke-filled room you wouldn't be able to see a thing. Conventional thermal imaging system, you're holding it like this and you're looking into the screen. And that's where we work very closely with Scott Safety, identifying gaps in the technology market to be able to embed this into a product. This bit here is the camera. That there is the in-mask display. This camera is sending information wirelessly, which means that we don't have to penetrate the mask with a cable. What you see in the display inside the respirator is thermal signatures of whatever's there, even if there's a fire in the background. Significantly, that firefighter can still scan the room and find the victim. You can imagine the environment in which these products go in. They don't really get treated that well, even though they're technology. So the fact that the firefighter can forget it's there and go in and it can live up to whatever they're doing was the real challenge. The benefit of this, the fact that both hands are free, they have a screen they can look at whenever they want. It's always capturing the thermal scene in front of them, so they've got way more information whenever they want it. It's a proud day when you see such an impactful product improving people's lives.
Alright. How's this light level? Everyone be able to stay awake with it? It'll make seeing the screen a little bit easier, I think. So that's the Scott mask. Initially, Lisa and the Fire purchased them for every apparatus. They came out for the paramedic and also for the captain. It's pretty high-speed technology, but when we got them, we encountered quite a few hurdles. So, move forward. Oh, I go back. Fantastic. I'll bring this with me. Oh, good. Okay. Now we're good. Okay. So, we bought in right when these came out. We got the first generation of Scout Sight. Ran into quite a few hurdles with them, which you expect with new technology. Only one was assigned per truck, like I said, it was to the officer, the paramedic seat. So they are still in circulation, though they are not widely used or frequently. And that was for a number of reasons. So without jumping into those yet, what are some of the benefits that you could see with a mask like this or expect to see with them? And what are some of the hurdles? Let's go with benefits first.
Hands free.
Yeah, hands free. You don't have to have a tick in your hand. You have both hands able to do whatever you need them to do. Forcing a door, pulling ceiling, pulling hose, moving objects. You can't set it down either, so you don't lose it, right? What else?
That's one less thing to forget to grab while going to the fire scene.
Absolutely. Yeah. And it incorporates right into the masks that we already have, right? Justin, do you remember when these masks rolled through?
Yep.
What were some of the issues that we encountered?
Connectivity.
Mhm.
Trying to pair it from the actual camera to the, like the camera itself to the site.
Yeah.
Batteries.
Batteries. Oftentimes people struggled even when following the manufacturer
I think
recommendations for
one of them
powering
got
down.
left on versus the other and it would just end up dying.
If you didn't get both devices shut down, the battery life was not very long. Talking about some limitations, right? So they are mask mounted. They are fixed. That means there is no adjustment to them. Typically that's not a bad thing, but people with different eyesight, we often found people using them had to look up in order to see the screen, almost as though you're looking past glasses or down your nose or something, which exposes the face to things dropping and kind of reduces the effectiveness of a helmet, right? The screen resolution wasn't fantastic. It's obviously very small, as you can kind of see in the corner there next to that valve. It's real little, not a lot. Being close to your face, you can see a decent amount, but you still had to be able to focus on it. And again, eyesight became a hurdle. We had a lot of people that wore glasses who don't wear them in their masks, and if they had the mask-mounted ones, they often couldn't see the screen because those sat higher. The resolution, like I said, not being great. It was a single mode, so no matter what, it saw the same sensitivity. We'll discuss that more later. The battery, that was obviously identified. And then it was 3.5 ounces. Doesn't sound like a whole lot, right? 1 pound, 16 ounces. Does anybody like to backpack? Mr. Military, do you do a lot of rucking?
Yeah, ounces equal pounds.
Absolutely. So a 3.5 ounce weight on one side of the mask gets really frustrating really quickly, especially when you have people whose faces are shaped differently and seals are hard to attain normally. That became an issue. Another big problem we ran into was when COVID hit, right? Now we had to figure out how to decontaminate a mask between each member utilizing it. So if every shift you had to deep decon this mask, it became very cumbersome very quickly. So people began to utilize their own again. It was just some of the hurdles we ran into.
I think another thing was the camera itself connecting to the site
Mhm.
and the delay it had whenever you're scanning a room.
Yeah,
It was a
moving
pretty
so
big
quickly.
display.
It's a small camera, the processor's not very large, so when you scanned, you had a lot of image freeze. It would almost skip going across the room. So it was really better when you were standing still looking at one isolated object. Doesn't happen a whole lot in active fire. Alright, so small, face mounted, lightweight, hands free. You couldn't drop it. You could snag it in theory, low likelihood. They were powered by AAA batteries. Let's see the laser pointer. It does not show on the screen. So over in this side, you obviously have your display within there. You may or may not be able to see, but that camera is showing a firefighter in a controlled burn environment with heat overhead. That is the size of it. You have your temperature range on the right-hand side, as the video showed. They were kind of easy to turn on, in that you just had to push the buttons the right amount of time in the right order. Limitations, again, small sight picture, the angle was difficult. If you didn't turn them off, there was a proper sequence. They would not have an auto off feature, so the batteries would die. And then of course the weight. These predated our Seeks, so that was one of the benefits to having them. The officer has their own, so the firefighter could utilize the handheld. and it did require the sharing of masks. Germs are bad, right? Don't want to get them. Next, we'll talk about the Seek Fire Pro 100. Let's get my mouse to the right screen. Oh, got lost. Come back to me.
You're up there.
Okay, fantastic.
Safety in the fire service is imperative. Being able to perform the job safely and easily and quickly is critical to their ability to return home and also to get the operation done in a rapid manner. The Albany Fire Department was in need of thermal imagers, and we'd like to get thermal imaging cameras for all of our riding positions. We have a multitude of tools to carry. We're pushing 60, 70 plus pounds of additional equipment to go into a fire, and having a lightweight tool that is a multi-purpose tool helps to be run over by members of the fire service that utilize it every day.
Having the Seek in every riding position is a huge benefit to us. They're able to move faster and they're able to locate the scene of the fire faster. They were able to do searches more quickly.
Use of the thermal imager is not just for firefighting. I feel our members have turned it more of a multi-purpose tool. We're finding that in the hazmat situation, we're able to look at levels of tanks, and we also are surrounded by highways. We're a major transportation hub. So we have a lot of product flowing on the highways. So in the event of an emergency, we're able to quickly evaluate the amount of product that's in these vehicles with the help of thermal imaging.
Every member has the ability to have thermal imaging, not just for fire attack purposes, but for a multitude of calls.
Dispatchers received a call that two boys, ages 7 and 8, have been reported missing south of 151 near Morgan Road. Last seen, approximate time is 5:30 p.m. Request search and rescue teams.
It's inspiring music. Scroll back. Go back. All right. So, Seek Fire Pro 100. This came to Lisa Fire in 2020. We acquired them following a group of guys going to the IAFF Affiliate Leadership Training Summit, ALTS, in LA. 2018, they ran into some firefighters out there that were utilizing them and spoke nothing but positives for them. I'm going to pass this around, take a look at it if you need to. We attached one to every single air pack, and they're small and inexpensive, which is what made it possible for us to do that. It's also widely considered a great success because of those things, right? Early generations and technology advances have kind of left this generation in need of replacement. So we are looking at different ones. Having said that, these still function pretty well as long as you don't expose them to high amounts of heat. Unfortunately, most fires require high amounts of heat. And one of the other issues we run into more recently than not is that there's a lot of challenges getting components for these to be replaced. There were 2 iterations of the 100. A lot of ours, that one in particular, is the first. So repair parts and pricing becomes very difficult for us. So have you guys all utilized these on fire grounds and training opportunities? What are some of the benefits that you found with it?
Small.
Yeah.
I like how each pack has their own.
You never have to worry about not having it, losing it, any of those things. What about some of the drawbacks? Have you run into any?
Winds can get pretty nasty depending on like moisture environment.
The screen, the display screen?
No, the actual lens, and which obviously affects the display, and then taking your structure glove and kind of clean it out as a paint.
Yeah, because your glove's typically also dirty. Anything else?
I think the lanyards aren't very high quality either, personally.
That's fair. Alright. So when these came out, these sticks boasted a high resolution camera relative to the size and the cost of the piece of equipment. When we got those, they were, I believe, $500 a piece. It's not bad considering that the MSA 6000 Plus was 18. Big difference, right? They incorporated photo mode, so we could have stored pictures just by simply pushing a button. It's the top right one on the screen, and that allowed us to potentially have application in fire investigation later on. You can capture a photo while you're going through. You can potentially have a display of what's going on for the investigator who wasn't on scene or interior at that time. That can help them get a more thorough investigation completed, and that has lots of downstream effects. This camera does feature multiple modes, and when I say modes, it means the camera's operating in a different way, right? We have fire attack, which is a white hot mode. We'll kind of discuss the science behind that in a little bit. That's the picture you see on the left of your screen. That's what we're all used to. That's our fire mode, because in that, black on the screen is going to be cooler than white. There is a gradient that's shown at the top of each screen that kind of establishes how far they go up. So if you look at it, this gradient shows 65 to 85. That gives us our temperatures. You see 85 underneath the helmet, that's probably coming off their head, right? Core body temperature being 98 plus, makes sense. You have color mode, which was built in as a demonstration purpose. That's the one we see in the middle. And then survey on the right. That one has several applications. It's good for 360 and initial size up, as well as finding hot spots and overhaul. The flashlight also incorporates a built-in 300 lumen flashlight. So if the one that's mounted to your coat or your helmet, if you have one, fails, you still have a backup. Here's a question for you. Does the unit have to be on to use a flashlight?
No.
Kind of looks like you're doing it right now. It does not.
It's on now, but
Which is one of the benefits to it. All right. Moving on, we're going to talk about something that we actually don't have yet, right? This is the Seek Attack Pro. It's Attack Pro X. There's the S model, which is what we're currently speccing. This is Seek's latest large handheld thermal imaging camera product. And we beta tested it last fall during our live burns. I'm part of the 1403 cadre, so I was fortunate enough to get to put hands on with this and take it into a fire room. I gotta tell you, it's hard not to be biased towards this product. It's pretty fantastic. We're gonna watch a brief video on this and then discuss it in more detail. If I can find my mouse. Okay. Oh, there it is. 3 screens is a real bear to navigate. Their PR guy definitely stepped the game up, right? Come back. There we go. All right, so some things about the Seek Attack Pro. like I mentioned, we were fortunate enough to beta test it last fall. Lucasfeld Fire allowed us to utilize it for a whole round of our live burn evolutions. It came back with resoundingly positive reviews on it. We're in the acquisition process right now. Speaking with Assistant Chief Blancett, we are looking at potentially getting this paired with some of the newer small Seeks that are available as well. So this Attack Pro is a substantially enhanced thermal imaging camera when compared to our 5200s and even the 6000s. They've really kind of jumped to the forefront in some of their technology capabilities. A lot of other companies are actually acquiring some of their proprietary technology and incorporating it into theirs. It's the latest heavy hitter on the tick scene. It's a small profile. The unit itself doesn't actually have a traditional D handle that we're used to on the MSA thermals. If you guys have ever used Bullard, it doesn't have a big handle either. That's helpful because it is a reduced profile. When we're trying to get through smaller spaces or worried about it snagging and getting caught, it's pretty awesome. Has anybody in here put hands on this one before?
I think we did during the live burn.
Yeah.
Last year.
Do you remember how you felt about it?
Same thing. I mean, the technology was way better than what we're used to. And I think it was a little bit heavier, on the heavier side, was it? Or was that the other one we were?
The 6000 was not the lightest. This is pretty light, all things considered.
Were we testing another one last?
We're just using, well, we had a small Seek that we were also utilizing. We used the yellow one. So when we talk about technological advancements, one of the big things that this thermal brings to the table is the ability to use mixed gain mode. It also has really enhanced refresh rates. The image clarity, as we saw in the video, is pretty high. Color gradients are a little more broad. And that mixed gain, like I said, it's a game changer. Before we've had to deal with high sensitivity, low sensitivity, which we'll talk about here in a little bit. This has a blend of it and it can see both, which is pretty incredible. Next. All right. So it's the latest technology. High and low is now incorporated into mixed gain. What does that mean? So you have high sensitivity and low sensitivity options, also referred to as gain when looking at thermal imaging cameras. MSA does a great job of differentiating them. The high sensitivity is one that's utilized in lower temperatures. It's a little bit inverse here, but because the input from the fire or the heat source is lower, it has the ability to use the full capability of its processor effectively, right? That means it can see more detail. At a certain point, 302 degrees Fahrenheit, it will have to switch to a low sensitivity mode. So the quality of picture is slightly reduced. However, the camera is now open to a larger range of temperatures, and it will slowly develop a better sensitivity the higher it gets because you'll have contrasts, right? Having mixed gain means that you can do both, right? So this doesn't require a percentage of the infrared sensor to be saturated with a certain temperature. That's the difference between the MSA and the Attack Pro, where those require, I believe, 37% saturation for it to flip. This Attack Pro can see both. It'll keep running high and low sensitivity and put it in a combined image. Temperature range goes up to 1022 degrees with the color display. The enhanced field of view, so it's wider. It's 57 degrees by 42 degrees. I know that probably doesn't sound like a lot, but we'll see it in person, hopefully in the near future, and it'll make a lot more sense. The refresh rate's pretty solid, 25 hertz. There's very little lag in this. Lag is one of the big issues we've identified with the MSA, so we'll talk about here in a bit, right? The flashlight, also being 300 lumens, is pretty awesome, and it's got its own single function button, so you don't have to cycle through a menu to select it. So, going through some of the operating modes on that camera. I wish we had one in person. Unfortunately, we don't currently, but we're going to discuss it as if we did. Mixed gain is run through SV1 image optimization, which enables the visibility of the hottest and coolest regions without manually switching modes. That's the easy way to think about how I just explained the pixels. And this eliminates the need to freeze the image or to toggle between high and low gain or sensitivity modes. Basically, it simplifies the operations under duress or in fireground. That matters because one of the biggest issues we hear with the MSAs is lag, screen freeze, it's skipping. And that's in large part because the camera's trying to cycle between high sensitivity and low sensitivity. And when the image is manipulated within it, it now has to play catch up. It's kind of like just going through too many windows at once. So the display has a 320 by 240 resolution and it's 2.8 inches, which again, doesn't sound like a lot, but given the size of the camera and the detail, it's pretty fantastic. As the video illustrated, the battery life is expected to be 6 hours of continuous use per battery charge because they operate with lithium ions. And some durability aspects, referencing these NFPA standards, right? We have IP67 rating, so it's water and dust proof. They can be submerged in a meter of water for 30 minutes. What's that in freedom units?
3 feet.
There it is. It is drop resistant, so it can survive drops of 2 meters, 6.5 feet, onto concrete. The heat resistance has been substantially upgraded on this one, so now it has a heat resistance of 500 degrees with the housing that it holds, even though it's plastics. So it's designed for extreme fireground conditions. One of the hurdles we run into with our ticks currently is that we're having issues with them in these burn rooms where we're getting them to 600 or 700 degrees, even up to 8 momentarily. These cameras aren't designed to be fireproof. That would be very difficult to do. They'd be much heavier, much more expensive because the materials would change. Ideally, we would not be exposed to those conditions for long periods of time, which is where those components begin to fail. A quick flash at a certain temperature may cause surface damage to the plastics. It's that long-term exposure when you're in a high temperature environment for 1, 2, 3, 4 minutes. That's where we begin to have issues. So weight-wise, Mr. Yeager, you were talking about the weight of it. It weighs 1.4 pounds, 635 grams to be exact. So it's pretty robust, but also manageable, right? I believe those MSAs would weigh quite a bit more than that. We'll get to that here in a second. And then certifications. So they mentioned in the video that this is a certified unit. That means that it meets the NFPA 1801 2021 edition certification for stringent fire service standards and performance of durability and safety. The base level Attack Pro meets every major fire industry standards, but isn't explicitly NFPA certified. That's where the plus comes in. Any questions at the moment about this device? Here's what we know, the MSA evolution. So the evolution series at its time was pretty innovative. When we introduced it to the Elizabeth Fire Department, it was considered to be top-notch product, at the top of its game. At the time, it had many groundbreaking technologies, including the high and low sensitivity modes that we talked about. Auto switch, that was tremendous because no longer did you have to press a button and ensure that you were in the right mode. And it had a standby, so if it wasn't having a change in display, it would recognize that and turn itself off to save battery life. Also really important because as firefighters, we always walk out of the house or burn building with our flashlight still on until someone tells us to turn it off. We do the same thing with cameras, right? So when we acquired them, the department put one on every single apparatus. Most of them still have one of these iterations. This allowed crews to operate with safety as well as aggression. We want to make sure we're doing our best to be efficient. We now have tools that can help us. I'll reference this multiple times, but recall that these thermal imaging cameras are still tools and don't replace the basic firefighting tactics, they enhance them. There are several of these still in service. Many have been rotated out due to battery issues or components no longer being supported. So that is one of the things we've run into. I'm assuming everyone in here has been hands-on with this, right?
Yes.
Awesome. So let's talk about some of its modes, right? The ability to switch between high and low sensitivity was at the time groundbreaking, truly. High sensitivity is, like I said, low temperature range. Low sensitivity has a higher or wider temperature range, but it also has a decreased resolution, so it wasn't quite as good. That was problematic because if you didn't switch from high to low and you exceeded that threshold, your image became shrouded. It was all one because the temperatures increased, so you effectively had a screen whiteout. You couldn't actually see anything, just the level of heat being reflected. The automatic switch took the user error out of that. Does anybody know how to tell when they're switching? between high and low sensitivity? There's a visual indicator.
The temperature range?
Well, it hits a threshold. So when these switch, 32% of that thermal image saturates the sensor at a temperature above that limitation, 300 degrees, 302. At that point, once it hits 32% of the sensor reading that, it will say, hey, it's time to switch to high or to low sensitivity, and it will do that automatically. You know it's switching automatically because there will be a green triangle displayed in the upper left-hand corner of the display screen. That's your indicator that it's switching modes. Have you guys ever noticed that? When we go to switch modes, what tends to happen quite a bit? Does the screen freeze up? Maybe locks on an image, or maybe it skips and looks really, really rough. It's not helpful, and everyone says, man, this thing's a piece of junk, gotta get rid of it, right? Really, if we just held it still, it would, for 3 to 5 seconds, it would switch over mostly seamlessly, and we'd have the low sensitivity operating, as long as we're maintaining saturation. One of the hiccups that it runs into with this auto switch, which is where the Attack Pro's mix gain is a huge step forward, is if we're playing right on that gradient line. We're somewhere in the neighborhood of 300 to 330 degrees. It's gonna have a hard time maintaining low sensitivity or high. It'll constantly switch back and forth depending on what the sensor's pointed at. So that's when it becomes kind of ineffective. So this comes from the MSA bulletin that came when you requested information on this item. It just kind of highlights some of the things that we talked about. The instant on feature for this camera was pretty fantastic. It didn't need a long boot up time. Typically we start within 2 seconds or less, but you depress the power button, which is located here. We made it green to be firefighter proof. You can all tell this is different than down here, right? So we press the power button, boots up. That was less than 2 seconds. Still does, even being 20 years old. It has a 160 by 120 focal plane array, which speaks to the resolution. So 19,000 pixels. Unless someone here is really big into that stuff, that may not sound like a really important fact. It just describes how well the resolution displayed on the screen. The Heat Seeker Plus option would identify the hottest object in the room in both high and low sensitivities. There is a numerical guide, which is located on the bottom right corner of the screen. We'll pass this around and everyone can get hands-on with it. That references the temperature that the green dot in the center of the screen is pointed at. You can utilize this. And then the high sensitivity imagery. So this, at the time of inception, had high sense imagery that's 2 to 4 times longer than the competitive cameras, meaning it was simply put more effective. It was way more effective in high sensitivity, which is important because when would we use the camera, what kind of operation would be used in high sensitivity? Recall that high sensitivity is up to 320 degrees Fahrenheit. Search, right? Having a really high quality, high sensitivity camera, that would be a game changer for search because now you can scan a room and while someone is conducting, if it's a large room, you may be jumping in and swinging off and doing a hands-on search. The officer may be standing at the door doing a sweep. They can say, hey, Austin, go to that far right corner that looks like a person over there. They can identify them. It expedites the ability for us to locate victims or things we're looking for specifically. So that becomes more efficient. Here we have a display of both high sense and low sense looking at the exact same thing. That's a firefighter's rear end. Can't tell. Oops, let's go back. So looking to some of the resolution quality here. High sensitivity means we're running 115 right now to 300. We can see quite a bit of the coat and detail. We can tell this is an air pack. There is your valve telling us it's a Scott, so we can turn the bottle on, right? We can see things if we look at it for more than 2 seconds, right? But when you go to low sensitivity, our eyes are immediately drawn to the temperature gradient because the detail down here is not very good. That means that when we're looking in a very hot environment, over 320 degrees, we may not be able to see a victim very well because they're going to blend in with their surroundings. We're going to get focused on the color gradient instead. Again, incorporation of mixed gain mode with the Attack Pro kind of eliminates that, and it's pretty fantastic. Next, we'll talk about the 6000 series. So, this replaced the 5200 series on multiple trucks, but unfortunately did not capture all of them. It was brought forth because the 5000 and 5200s were aging significantly. Again, they've been around for between 18 and 22 years, depending on which generation you have. It is MSA's still premier product, but they are really expensive. So these cost $21,000 now. They were 18 when we got them. They are pretty awesome as far as comparison with that camera. The resolution is substantially higher. It now features a flashlight. I mentioned earlier we have a laser pointer. We'll show that here in a second. And this has multiple modes where that one simply has white hot. That's it. That's all you get. So this model came with a larger handle. That was one of the big differences. Why would we need a larger handle?
Gloves.
Gloves, man. They probably gave some consideration to that, but lots of years of trials and errors, they found the larger handle much easier to manipulate. Everyone's got different size hands, but they're all big with gloves on them. It's also ergonomic, so the profile of this fits your hand a little more readily. The buttons are pretty easy to push. When you have multiple ones up here, we'll pass it around. And it allows us to still hit these buttons because they're large with a gloved hand. So to power it on, it's very similar to the 5200. You have an obvious green power button right here. Again, firefighter proof. Which pulls up in 2 seconds or less, just like the 5200 did. And it comes right into what is programmed as your initial mode, and that will be the white hot mode. So it'll automatically change between high sensitivity and low sensitivity just the way the 5200 does. And there are different color gradients. I'll pass this around so we can kind of get hands-on with it. Quick reference though, there are multiple buttons on the screen up here. You have the ability to zoom in now, which we'll cover more here in a second, simply by pressing the magnifying glass. You have mode selection over here, so we can cycle through our different modes. And on the front side, we do have a small black trigger that activates the flashlight, and a second push activates your laser pointer. Third turns them off. So, some of the things to deal with the color gradient. Thank you, Chase. That will denote the temperature. This does have a display, again, for temperature, but the accuracy at best is plus or minus 18. So it wouldn't be used as a thermometer of sorts. Plus or minus 18. It has rechargeable lithium-ion batteries, IP67 rating, just like the Attack Pro. There is our display size and dimension. So it's about 1 foot tall, and at its largest depth, it's 7.3 inches. Our display is 3.5 inches, where the Attack Pro's is 2.8, size differential. The range on this is pretty substantial. So this one operates in high sensitivity from -40 to 320. That was a departure and an increased range over the 5200 series. In low sensitivity, it can operate between -40 and 1112 degrees. That's much higher given the last one was roughly 1022, right? That would be pretty helpful for identifying different levels of heat. And also bigger numbers are always better in the fire service, right? Calls, fires, all of it. The field of view is slightly larger. You have the ability to capture images on this one as well. It's got a 60 hertz frequency, so it does keep up very well with the processor. I see Mr. Yeager is exploring the modes button. We'll get through those here in a minute. And its runtime is nominal at best, 3.5 hours as compared to the 6-hour battery on the other one, the Attack Pro. All right, so side-by-side comparison. This is a difference of roughly 15 years in technology. Quite a bit's changed. The 6000 now features a 2x and a 4x zoom option. You have 6 selectable color palettes. Eagle-eyed users in this room may have noticed there's also a compass on the Attack or the 6000. That's just an additional tool to help you improve your situational decision-making process. So, let's see, moving to the next piece. Obviously, both of these are designed for firefighting and emergency response, supporting tasks like fire attack and suppression, search and rescue, ventilation, overhaul, large area search. They're built to enhance firefighter safety and situational awareness in low visibility and high heat. Both of them have high and low sensitivity modes. Both of them have the heat seeker technology, which provides color indicators for different heat sources. Durability standards, pretty similar. They're engineered to meet IP67 ratings and meet NFPA 1981, which is the heat and flame exposure test. Near instantaneous startup, 2 seconds or less for both. They have RFI resistance and reliable battery systems with lithium ion, reliable being subjective. I think they are for a certain amount of time. And temp readout is pretty easy to use. It automatically adjusts between Fahrenheit and Celsius depending on what you select for programming, and it's pretty quick feedback. The gradients mimic the same, it's displayed the same, so it makes it easier for people to transition from one device to another. Some of the differences. The image quality, the 5200 has a 320 by 244 resolution, as does the 6000 plus. Difference being the enhanced processor results in sharper images in the 6000. Temperature range, we already identified that. The low sensitivity runs up to 1022, and the 5200, this one runs up to 1112. The Heat Seeker Plus is offered in both items, but the 6000 has an enhanced version. So the gradient shading provides finer temperature transitions and better visual cues across both modes. There is no zoom or compass on the 5200. The 6000 has a 2 and 4x zoom, the color palettes, the flashlight, laser pointer, and the ability to have wireless transmissions are optional upgrades, as well as the ability to take pictures. Weights. So the 5200, slightly heavier, 1.5 pounds. The 6000 plus is 1.4 and is more ergonomic. Justin, do you recall the weight of the TAC Pro was?
1.8.
Slightly heavier. Battery life, when they were new, the 5200 boasted a 2-hour battery life with camcorder style. There's a 6-hour option with the charger. The 6000 is supposed to be a 6-hour standard, however, that is with the upgraded advanced lithium-ion technology that leverages longer runtimes with the cost. And finally, the operational differences. The 5200 is simple. It has one mode. It's consistent, and it makes it easy to train with. The 6000 is more intuitive. It does have additional warnings like an over temperature and a shutter mode. And the mode switching allows for use in diverse different scenarios. Basically, both of them share the same core strengths from MSA, right? Durability, dual mode imaging, high and low sensitivity, and a firefighter-focused design. They designed the handle larger because it fits a glove better. That's what it's for. It's rooted in safety and reliability. The big differences being the image quality, technology, temperature ranges, heat seeker, all of those things. So, like I said earlier, bigger number means it's better, right? Mostly. 6000 is better in almost every way, and almost is the key there. There were a lot of technological improvements. It's lighter, stronger, smarter, faster, longer lasting, more sensitive, more expensive, and the field of view is where it really takes a hit. What that means is low sensitivity in the 6000 isn't activated until 32% of the field of view is above 300 degrees. That means that we have to point it directly at a larger heat source for longer to get it to switch modes. It doesn't have the sensitivity in that way that the 5200 did. So, let's talk about the color palettes. And check time real quick. Yeah, we're getting pretty close. But we can make it through some of this. Alright, so the 6000 offers 6 configurable color palettes. You can program them in whichever order you prefer, but this one is typically white hot, is almost always the very first one. This is, like I said, pretty substantial when you didn't have that many options beforehand on the 5200. That has led to some issues though. Because they're programmable and you can add or exclude different color settings, where would we run into issues with that in the Fireground? Getting lost in the wrong mode, not sure what you're looking at because it's different. That can be pretty problematic pretty quick. So, pop quiz, what does the green triangle in the upper left corner of the screen mean?
Transition
From?
sensitivity to high sensitivity.
Fantastic. Why does that matter?
You know what you're looking at?
Know what you're looking at? The depth of resolution, right? What else changes when we switch over from low to high sensitivity? Or high to low, excuse me. Think about it in terms of what the colors tell you.
Well, in one setting, white would be hot.
right?
First, yeah, everyone.
White's still hot, but now the black color can be 300 degrees still, the temperature gradient. So you have a depth or enrichment of black. That matters because when we're looking, if we're on search, or even if we're on suppression and we're going into a room and it switches over to high sensitivity, that object in the corner into the low sensitivity, the one in that corner, maybe a person, pretty obvious in high sensitivity mode. But when we switch to low, one, we get distracted by color gradients. We can look at the thermal exhaust vent coming through, so that's distraction, it's moving, it's got color to it. It also means that the shades are harder to denote. So victims, down firefighters, exits now become harder to see because it's falling in that black gradient. You have to be able to denote between different colors of black and dark gray. So another thing too is that when we're in high sensitivity, right, the reds that we see, we associate with heat. 300 degrees is pretty warm. I wouldn't put my hand on this thing for more than, I don't know, half a second if it was 300 degrees. And even then, I probably shouldn't have done it in the first place. When that green triangle hits and it switches, now that reads as cool. It's showing as black. So if we get separated, lost, collapsed, and we're reading in low sensitivity, and we see something that's black, our brain will associate that with cool. That can be problematic. If we're looking for exits, harder to find. In the event that you start to have equipment failure, you may trust that, oh, this is going to be fine, when in fact it's 300 degrees and you still need to get it cooked. I know it kind of seems backwards, but that's how MSA has built it. So, I guess the easy way to think about it is driving into sunlight. When we're looking at sunlight with our eyeballs, just straight eyeballs, right? It's bright, it's hard to see through. At a certain point we say, okay, time to put sunglasses on. When you put your sunglasses on, some of the colors may wash out, some of the detail disappears. It's the same way with how this camera operates. So we talked about exits. How else could this be dangerous? If the details disappear and the color gradients change, when you're progressing through a structure, are you going to be able to clearly define the hole that you're 2 feet from in the floor? Possibly not, right? What about the red triangle that shows up in the center of a screen? Does anybody know what that means? We obviously don't see it very often. Take a guess. If the left is green, it's telling you it is transitioning modes. What would red say? Think of color gradients.
Just the temperature is getting dangerously hot.
Over temperature. If you ever use this tick in a fire and it's showing red, a red triangle in the center of the screen at the top, that means you are in a bad spot. Your gear and your ears will probably have told you that already, but they built in a safety feature on the 6000 just to make sure that everyone's aware this is probably bad, right? Actually, let's talk about color gradients. We have 6 total. So black hot, not typically used. That's the inverse of what we are accustomed to. In most thermals, the white portion is the hot part of the screen. In these, it's inverted. Again, can be very problematic if you utilize it in fire because now things that are black you associate with cool, they are not. In fact, they are hotter and hotter. Red hot is kind of a gimmick we'll talk about in a minute. We have the rainbow patterns, the iron bow, and the fire and ice. This is all the exact same image, just inverted through their different mode configurations, color palettes. So white hot, this is what we're used to. This is what we do every day. It's simple, it's easy to use. It was the original display. Color does not show up on these cameras in white hot mode until it's over 1,000 degrees in low sensitivity or 291 in high. That means we're seeing shades of gray and white. The white gradient becomes more and more intense as it increases. Obviously, we're looking at the wheel of truck 7, even though it says 2. I promise you it's truck 7. It's now been fixed. There's a lot of heat coming off that engine. If you look very closely in the center of the screen, you can see a little bit of the exhaust pipe. That's coming off the motor. That's hot. That has color to it. The rest of it, still pretty warm, but it's white. Obviously, as we're going through color gradients, you guys all probably know this, but yellow, orange, and red indicate color increases. When temperatures exceed a threshold of color, it overlays the white hot base showing heat or fire progression and adds detail to it without switching modes. The black gradient will reflect the lowest temperature in a space. This is, again, the default setting, and we use this on almost every application, scans, 360s, and search, and fire attack. It's preferred in dynamic situations, again, because exertion may become a factor. This is why it's the first program. It's what we're used to, so we fall to the lowest level of training. If we're very well adept with white hot, that's what should be what we default to. This is the exact same reason why if you turn your radios to 1 or 15, you still get dispatch. In the event of an emergency and your brain is not working like it should, you can still get somewhere you need to be. So this simplicity means that we don't have to worry about having to process it. We can still function because this is a tool and we still have a lot going on around us. Much like our portables, so when we power them off, like I said, this allows us to return to the white hot setting by turning the camera off and back on. So if we get lost in a separate mode, we can turn it off, turn it back on, it's going to populate in white hot mode. So some things that this is representative of, right? The enhanced resolution on the 6000 compared to 5200 means that we can see a more detailed gradient, we can discern more detail, always good. We can also use the Heat Seeker Plus, which will basically, once the temperature exceeds the threshold, the gradients become displayed, and that's a wider band as opposed to 5200. Obviously, cycling through the modes will not be difficult with these large buttons, so let's cycle to the next one. Black hot mode. This is the reverse of white hot, as it sounds. Objects in either hot or black and cool or white. You still have the exact same color gradient with yellow, orange, and red in that progressive order, and it is helpful in bright environments where the screen may be difficult to see. Our monitors do the same thing, LifePak 15, that's why you have the inverse mode. Once again, colors don't show up until it's over 1000 in low sensitivity and 291 in high. We talked about why this is critical for firefighter and operations because our brains are used to this being inverted. And we talked about the dangers of this. Fire and ice mode. This is the third slot in our cameras. If you still have that one over there and we have enough battery life, you can cycle through to fire and ice. It functions very similarly to the white hot palette. Difference being that you have a grayscale at baseline, and the higher temperatures are red with lower temperatures in the room displaying as blue. So the white hot kind of covers the in between. It's great for quick differentiation of temperatures. As you see on the screen, you have the cool floor on the right in that photo, and the hot undercarriage on the left. It's not ideal for firefighting operations because heat's everywhere in those, right? Iron bow. This is the fourth one. It's got a great name, sounds cool. Heat registers as dark purples and progresses towards yellows and reds based on the ambient environment. As you can tell, these are all focused on the exact same location. So when we have color gradients like this, or like this, and we're progressing to this, if you're not familiar with it, this would be very confusing. High temperatures do provide washout. So what that means is the screen becomes the same color across the entire thing. It's not intended for firefighting operations, but when could this be useful?
Hazard checks.
Hazard checks, yeah, absolutely. What else? Search, overhaul, locating stuff in walls. Think about it this way, if you're in a smoky room, the iron bow shows you a purple floor, yellow walls, and a red fire seat. So redder patch would mark the fire's core, meaning you have different colors beyond the normal grade you're used to. They're more vivid in contrast. Sometimes they can be, easier to process. Rainbow ray. This is a vivid color ray as it sounds, all of the rainbow. It's really dramatic in what it shows. It is the fifth option to select, and it is not in any way to be utilized for fireground operations. This is basically just a demonstration only to highlight the camera's abilities to differentiate temperatures and create that complex palette. It speaks to the resolution and the ability of the sensors within the camera itself. All right, we are coming up on 1 hour. We're gonna take our next break. So let's all meet back at 3:55.
This one died when we go plug it back in.
Yes, we can try it. That'll be plugged in on our mid. Or if the pumper's on the shoreline, we might be able to pull it, but
Oh, okay.
you can try pumper. We'll see what happens. Did you you notice what battery life that was at? It needs to be charged before we go to our practicals. Alright. Justin, I appreciate your diligence with the student manual.
Doing my best.
We're gonna move out of the sciencey boring stuff very quickly, and it'll get more exciting.
Oh, I can't have break time.
Mm-hmm.
You having fun, Alex?
Much fun.
Alex, you hanging in there?
Use some ice cream after this.
No, I think we just might do that, especially considering that this will probably run in the neighborhood of 5:30 or 6. Might just be a special treat since our overtime personnel won't do so. But it won't make that much money. What do you got, 8 years?
7.5.
You're getting up there.
It's not like that much, but then when you look,
Yeah.
there's just shy of 100 people under me on the board department.
No kidding.
Yeah.
Gosh.
Isn't that crazy?
Yeah.
When I got
Well,
hired,
we had,
on-
I believe it was 75 under 5 years.
when I got hired, people with 7 years were still like the very bottom.
Correct. Sean and I were bottom on C shift for a very long time.
Crazy.
Alex, you want to go gather our compatriots? Please. Allergies are working this year.
My deck yesterday just covered in pollen.
It's that time of year.
Like a dark cedar color, and then now it's green.
Quite a contrast. Some may consider those accents.
Out behind the seat.
Alright,
Couldn't find.
we're gonna start back in. We're gonna get into some more exciting material. Let's talk about when to use a thermal imaging camera. As you can see, fireground applications. We've got size up, fire location, continuing observations by the commander of the fireground, and overhaul modes. We've got search and rescue, urban search and rescue, woodland search and rescue. We can use them for a lot of other things. NFPA 1408 states that ticks can be utilized for search, fire attack, investigation, overhaul, motor vehicle accidents, size up, hazmat, electrical emergencies, USAR, RIC, accountability, rehab, participant safety, vent, apparatus placement, water stream placement, exposure protection, water rescue, assisting PD, wildland operations, building construction, training, and other scenarios as identified by the authority having jurisdiction. They're a very, very wide use item. Can a tick be utilized on a gas line break?
Okay.
Not close.
How would it be beneficial on a gas line break?
You'd be able to pick up the movement of the particles, or would the temperature of the gas be different than the outside temp?
Temperature of ambient air and gas. Yep. So if the temperature of the gas being pumped is different than that of the ambient air or the ground temperature, it's going to show up. So we can use that to identify the flow. Again, remember, ticks don't operate well in water due to the refractory index or emissivity. So the water will distort the return rapidly. You can use them on the surface to some effect if there's something floating on the surface, but once you penetrate about 6 inches of water, it's pretty much worthless, right? When would we want to use that in water rescue? Specifically, when could we use one to our benefit?
Somebody just went under.
Just went under? Or think of time of day. When would this be more applicable?
Nighttime.
Absolutely. There's going to be a head or body part likely different temperature than the water surface on the surface. It's going to be a lot easier to spot somebody. Especially with the zoom available on the 6000, you might be able to zoom into an area where you haven't reached it with a boat and help guide. But also recall, these are tools, right? We have situational awareness cameras like the Seek, which for us really shouldn't be used as a decision-making tool because it is limited and doesn't have the capabilities or the resolution of this one. Really, that's more for if you get separated from a group involved in a collapse, maydays, it's great to have one. The decision-making camera should be the one that has the ability to cycle through modes, has a larger gradient, better processor, and that's going to be this large one. All right. Moving on, how to scan with a tick, right? You guys can all read, so we're going to kind of demonstrate this in person. We want to start low and work our way high. Why?
He rises.
Heat rises. Where's our sensitivity at? Higher on the floor, lower in the heat, right? So when we start a scan, it should be done low to high from the entry point of a room. This is where the nozzle man, the other guy attached to search, is going to make entry and call out that search we talked about earlier. The person, the officer, whoever has the camera, can be standing at the door and conducting a slow scan, moving from low to high across the room. Little thing about this, very similar to me, the display is wider than it is tall. So when I look this way, obviously I have front sight focus on it, and it's going to be scanning half of the room. If I rotate the proverbial gangster grip, as it's known online, now I can capture a wider display because the screen is wider, and I can see mostly from the floor to the ceiling. There's a small portion in this room that would be roughly, 8 inches, 10 inches, less than a foot, that you have to adjust to. But you can scan the floor and the majority of the room using the inverted grip there, right? The heads up position. So we don't want to be like this right in front of our mask looking at it, right? We always yell at our kids, don't sit so close to television, you're gonna burn your eyes out. What are we doing here? It's already hard to process on the eyes. Not to mention, I can't see much. Right now, I can only see Chase. Not great. It should be a heads up kind of position, honestly, meaning it's out in front of you, right? You can still look past it and evaluate your scenario. Again, this is a tool. It should not be what dictates all of your decision making. It should enhance your decision making. So you need to be able to look beyond it and still see with what you can. You talked earlier about the lens getting dirty and that causing a problem. So when that lens gets dirty, that's the receptor, right? That's where all the information comes into it. When steam, dirt, debris, dust, all of that hits this, it's basically rendered blind, right? We have to clean it. Cleaning this should be done in a very simple order, right? Ideally, it would be with a water-soaked, manufacturer recommended rag and detergent, gently cleaning in a circular motion, catching all the edges, right? That's not what happens in the real world. If we're putting water on fire and we get water return, that means we're getting a knock on it, means we're also getting steam and droplets coming back at us. That hitting this now puts water in front of the lens. Water has an emissivity of 0, or near 0, meaning it can't see anything. We want to clean that off. Everybody in here right-handed? Yeah? Use your left hand. It's your non-dominant hand. Most of your tasks that you need, that are going to get your gloves really dirty, are going to start with your right. You may use both hands, but we're typically going to have our right hand down when moving, right? To balance, that's just how it is. It's nature. Use your left hand, might be cleaner, and do a quick wipe of the lens. At that point, we would probably want to wipe our face piece, whether it's dust, dirt, insulation from the ceiling, or the same steam. If you wipe your face piece first, chances are it's going to fog up again before you get the lens clear and the image can draw up in this camera. By hitting the camera first and then immediately doing a soft wipe across your face piece, not a grabbing motion, we ensure that we're not causing any further denaturing of the plastic on your face piece. We've cleared this off. It has time to process while we're clearing our face piece, and now we get a clear image, and we can make a decision and move forward, right? And then the other thing, again, tool. Take a look, put it down. That's why we have the carabiners that attach to it. This one's obviously broken, which is not great for this example, kind of undermines our credibility, but we'll move past it, right? Set it back down and keep moving. You don't need to stare at this and walk this way. There are other times, obviously, when that's beneficial. But for the majority of our fireground applications, we're looking in a room and then we're moving. We're looking, we're moving. There we go. All right, another brief video time.
You gotta get low, you gotta read the smoke with your eyes, and say training before technology, sweep inside the doorway, call out fire department. That's a very basic thing. They may hear you, you may hear them. And your first scan, ladies and gentlemen, is your best scan. Before you shove your face in that tick into that smoke, and you have that moisture change where temperature change where your face piece fogs up and the lens fogs up, get low and take advantage of that. And then wipe that lens with your non-dominant hand. I used to wipe the lens with my right hand. That's a bad idea because my right hand is always down on the ground, searching, dragging, getting in the dirt. So I'm just smearing whatever I did on my face piece and on my lens. And scan wall to wall, flipping the camera sideways or gangster grip. And finish scanning back across the ceiling towards the point you're at. To make sure you check directly above you, slightly behind you. So instead of a 6-sided scan, you're doing 2 moves. Wall to wall with a slight finish over your head. And every time you get to an environment, another room, another entry point, you pick up the camera and scan. You do not, as we'll say in this next slide, you do not move with the camera in front of your face. That's why my search friends hate cameras, because firefighters scoop 3 feet, pick up the camera. Scoop 3 feet, pick up the camera. Or worse yet, they walk or crawl with the camera in front of their face the whole time. You're asking for a problem if you do that. You are. You will get disoriented, the camera's lights will go out, and you will not know where you're at, plus you're basically, you have huge depth perception issues, tunnel vision issues, the field of view is much more narrow than what your eye sees, even with a mask on. Don't do that, okay? You want to scan, communicate, put it down. Plus, if you're over 40, ladies and gentlemen, I got bad news. It takes a long time for your eyes to adjust from day vision to night vision and back and forth. So if I'm constantly staring at a bright light and then I go into the dark, my eyes don't adjust well. Quick 3 to 8 second scans can make a huge difference for information, and then put it down, and then move. So one of the things we also talk about is when you have that information, how do you communicate? We develop a simple model. We don't want a bunch of talking. Just like you hear somebody who's giving a size up and they won't stop talking, you're like, it says PTT, push to talk, not push to think. You know, the kid like, I got a 3-story house with vinyl siding and green shutters and pretty flowers in front of it. They don't care. My wife says it best, land the plane, honey. When you're about to go into a fire environment where seconds matter, I scan and I say, bedroom, crib right, or classroom, row left. If I get to scan before they go in, because if you're dialed in companies, you may get the first scan, they may take off and start split searching without you, which is fine as long as you can catch up and give them some information. We're not advocating that you have to give them all the information. There's no way possible. So give them a short directive, type of room, direction of search. And then you, as a company officer, need to be aware of thermal conditions, evac or ventilation points, closing doors. Don't sit there at the door with fire coming over your head. We see that too. Control the flow path. Locate the fire, isolate it. All of that can be done quickly with little bits of communication, if any, that you and your dialed-in crew can work out long before you get in the fire. You can practice these drills inside the firehouse on how you move and how you communicate. And this is why we tell people you gotta practice this, because if you scan too fast, especially if you don't understand how your camera shifts, this is what will happen. Camera pauses, triangle engages, watch. And the firefighter keeps scanning. This is not a seat camera, but you can see how he missed the fire, and I'll back it up. Pauses, triangle engages, you see that white grainy effect. Many firefighters think back to whiteout. This camera right here has something called FSX, which is flexible scene enhancement. It is just about to shift and add color to that white grainy nonsense stuff you see, but he didn't stay there long enough. He's not patient, nor should he be. It's hot, right? They want us to slow down.
Forward camera, but is that look familiar?
It's 1,000 degrees raining down your head. You may not want to sit there and be still. So it's a good idea to get that information before you get close to the target and understand when your camera shifts, how long it takes, because if it takes too long, you may not even use it to begin with, right? Whereas if we scan with an attack pro and a gangster grip here from our boys in Georgia, this is Bear as we go, you can clearly see the fire to our right. You can see the direction of the convection currents. That thermal layer, by the way, is not the yellow part, it's the white line under it. You can see the ventilation points that can cause us problems. If you look right here on your left, there's a window right here. That window fails, it's going to get really interesting. Tennis racket, nightstand, looks like a crumpled up mess of a bed. Who knows what's on the bed? You got to go search it. Camera doesn't do the search for you, it just tells you what it is. but that's how quick and easy mixed game mode in a suit is. Okay.
So that's the mixed game mode in the Attack Pro that we're looking at. When he's talking about there, though, that highlights what we referenced earlier with the exit points turning into black, hard to see, right? Thermal layering, the ability, when you rotate that camera into that gangster grip, this rotation, you captured almost that entire room, right? He's looking at a normal, common living room area. It's probably 15, 16 feet long, 8-foot ceilings, and now you can see the entire thing, right? Keep going.
And if you want to see why mixed game mode makes a huge difference for the win, we did this on purpose. We have a victim on the floor, and we're standing up, being a lazy firefighter, and all you see is the heat coming out of that next room. Excuse me, everything below you is dark. When I rotate the camera sideways, watch what happens. The floor that was dark lights up because of mixed game mode, allowing me to see now the victim, the furniture, the firefighters, and I can see floor to ceiling. And if you look really closely in that next room, there's a mannequin there. And the top half of that mannequin is colorized, which is not good because that's 300 to 500 plus degrees. Not good for human skin, okay? But that's the difference between lazy standing up scan, where the lower half is completely missed, to rotating it and getting that information and going straight to the victim instead of going, I'll just bump into it and I'll figure it out. You crawl around in the dark if you want to. My kid's right there, I want you to go straight to my kid, or straight to that bed. I don't want you to figure it out in the dark. We have enough technology and training to go find the victim or find the area of interest where the victim might be without staring at the camera too long. This is basic stuff. People think we're trying to turn them into videographers. We just want them to look both ways going across the screen. And when they're looking, a lot of firefighters have gotten very frustrated because they've seen this image on the left. The screen is all gray and you say the camera's whited out. Years ago, it was required to have training when you got these devices. And part of it was understanding if the lens was covered with debris or moisture, you would not see. So we teach a 3-wipe methodology. Wipe the lens, wipe the face piece, wipe the display. Lens, mask, display. Used to say, wipe the face piece, wipe the tip. When I realized, by the time I finish wiping my face piece, wipe the lens, come back, my face piece is fogged up yet. Because you're not promised what environment you're going in. If you're standing too high, you're in a flow path, high moisture environment, searching above the fire, you may only have a second, if that, before that lens or display fogs back up. So if you watch this flashover video, you can clearly see they are clear as day until we flow some water. This is a dreaded penciling application where we show thermal rebound. The heat returns right away. Watch what happens to the image clarity in just a matter of seconds. It's going gray. Well, many people would think the fire's going out. It's not. It's atmospheric attenuation. Moisture is building up in the lens, giving you a false image. He wipes the lens, look at that. Huge difference. It's like driving in a rainstorm and suddenly you turn on the windshield wipers and everything gets clear. So make sure you teach these basic behaviors, right? These aren't basic. And this is why you need to wipe the lens. This is what a grown man in the fetal position looks like 8 feet away on a very good camera, who's in need of rescue, by the way, where they don't wipe the lens. You wonder why people don't see victims? They don't even carry the camera or use it correctly. This man was found because the firefighter called out. You did not see him on the camera. The camera sees him, doesn't see it well, because the lens is covered with soot and moisture and who knows what else. You look there, we outline them for your view and pleasure. It's not always going to look white hot like I was taught in recruit school with the mannequin with the heated electric blanket wrapped around it, or baked potatoes in the burn building. Right? Well, what happens when I go in the fire and the lens won't clear? It's constantly fogging up. And that guy from North Carolina told me if I wipe the lens, I'd be able to see. Well, let's look at a contraindication. Look at this door. What's blowing out this door? We're supposed to be attacking the fire. Do you think we're flowing enough water here? Probably not. Should we be standing up? Probably not. Watch what happens when I follow them. I go in and turn right and go down 5 steps. It's like a split level. Look what happens to my image clarity. I'm in the flow path. I'm in the full exhaust. And a lot of us go, that's awesome. Well, not for long. It's not you. Get out of there. Okay, I've dropped down, get out of the flow path, wipe the lens, and boom. Image clears up. Heat's going above my head, up the stairs, and turns the stairs going to the right, which is where bedrooms are upstairs, which is not good. So that's one reason you may not be able to see. You're in a full exhaust. I reviewed 9 Maydays where firefighters went in full exhaust, didn't recognize it, and saw nothing but gray, never wiped the lens, and all of them were burned, one severely. These never made the news, never made the near miss reports. This is what happens around the U.S. Nobody talks about it because it's not reported, or they think something else happened. Their experience tells them one thing, the truth is another. This is why convection currents and wiping the lens is important. You go down this set of stairs, the lens is going to fog up for a different reason. Because you're crawling down the chimney. The fire is down the stairs to the left. A little warm, a little toasty. You don't realize it about 4 steps down and feel it coming up your boot leg. You realize, I'm standing on a barbecue grill. That's not good. And if it lights, where's it going to go? Up your boot leg and up to you. Not good. Okay? So, training to interpret this data as it's.
Alright. Just an easy way to enhance our knowledge here, what we were talking about a few moments ago. Alright. So, this is one of those interactive slides where you guys talk with me as the instructor, right? What are we looking at when we're going in for search? We can recognize ourselves in the camera all day, but how do we recognize victims? Where do we find victims? Okay. So if this guy's standing right outside the door, obviously that's the exhaust, that's the flow path, that's everything pushing out. He's going in a pretty hot environment. Depending on whether that's in high or low sensitivity, that tells you what temperature he's walking into. Looking over there, that's more of a controlled burn, so obviously have rollover coming through, but look at the gradients established at top. They're still in high sensitivity. They may still be quite a ways from the fire. One second. So this is the exact same image in high and low sensitivity. Look at all the detail you can see. You guys see the victim?
On the left.
Alex, can you find the victim? Can you see him on the right?
You can only see it because you.
Because you know it's there.
Yeah.
Yeah. So if we're rolling into a room doing search and we don't have that lens clean and we don't recognize that we're in low sensitivity immediately and we're scanning rapidly and moving, how easy is it to miss that person sitting against a wall right there, just outside the doorway? Where are most victims found?
By the doorway.
Right by a door. And we can miss them because they're leaning up against the wall. Is that realistic? Could that person be sitting against the wall, not laying splayed out, arms wide and making it obvious where they are on the floor? Absolutely. Reflections. Obviously that handsome devil there is reflected very clearly in high sensitivity mode. That's on the 5200. That's 20-year-old technology. Newer ones have even higher detail in reflection because it's a glass. Can you see through it? Windows, mirrors, full-length mirrors. You never know what somebody's into. Their bedroom could be all mirrors. Pretty hard to see, right?
I saw our reflections just sitting here in the whiteboard.
Exactly, because it has a high,
That one word.
yeah, emissivity, reflection. All right, so this is a photo of someone standing in the weight room, right? That is Assistant Chief Weisenbach. Can't tell unless you look at the arms really well. What do we see? Ambient temperature, 71 degrees.
Underdeveloped muscle tone.
No weight on the bar.
A lack of hair covering the top of the head. Right.
No, I didn't notice.
Do you have any concerns with this image? It's pretty clear. That's obviously someone in a room, right? How does this look if the room's 98 degrees?
A lot of white, probably.
A lot of white. Suddenly, that guy gets much, much harder to see. So fireground applications. We know quite a bit of this already, right? We reviewed the fire distribution. We've talked a little bit about flow paths through occupancies, different types, residentials, commercials, high life ones. Talked about smoke and heat dynamic movement, right? It goes up and tries to get out as quick as it can. That's why ventilation works. That's why it's awesome. Convection and fire spread. It goes through adjacent rooms, floors, walls, ceilings, anything it touches, right? Different types of fire present different challenges. how can that be summarized? We have a normal Class A type fire. Pretty easy to see, right? There's nothing in the way. Think about it, a normal residential structure fire. We have no idea what's burning. There could be lots of hydrocarbons. They could have fuel cylinders. They could have oxygen cylinders. I've run fires where oxygen cylinders exploded while we were making attack. You have things dripping down from ceilings, depending on what they manufacture in this facility. All kinds of different spread, right? You may have blowtorches where gas lines failed and it's spreading fire even further. That may be concealed because you have a large volume of fire on the wall next to it that it caught initially. So, our first usage of a thermal imaging camera on a fire call is going to be this. We're out on 360 attack, right? We've heard everyone say it on the radio before. During a fire, the first arriving unit should conduct a 360. The commanding officer coming in will conduct their own 360, and when Rick arrives, they will do the same. They should always have a tick when they're doing it. Even if the fire is obviously vented out, the tick can reveal a lot to us. It can show us the compartments of the house, some aspects of the layout. When we look at color grading establishment, you might be able to see where the fire is involved and you can't see it. They may have vented out of Division 2 on the Charlie Delta, but it may have started on Division 1 and it just vented out there because that's where the heat went, right? You might be able to see that the walls are really hot on Division 1 and know that we have fire on 2 floors because of radiant heat to the exterior. Using the tick on a 360, again, you shouldn't be walking, holding it up and looking, right? Every time I walk to a new side, quick scan, keep walking, looking for stuff in the yard, all the normal things, but you can use this to enhance your understanding of the building when you're doing a 360. Make an entry, right? So the video talks about doing a quick scan. Every operation is a little bit different. Personnel dependent, they get to be a lot really quick. We aren't fortunate enough to have 4 and 5 person apparatus every single day. That's awesome if we did, but we tend to do a lot with a little here. So when you walk into a house, do a quick scan. If you don't have a lot of smoke, maybe there's no need to. You can, there's nothing wrong with it. But if you do have heavy smoke conditions, this can orient you immediately. You can start to determine which way you want the hose line to make entry. If I kick open a door and I see that there's smoke billowing out, a tick will let me see, oh hey, there's a couch right there and an end table. We're gonna get caught on this little dresser they have leaning on the wall. It's gonna make an impingement point for hose line advancement. Now I know, hey, go that way, straight there. I can point the nozzle in to go in. It can show us the involvement, it can show us some of the heat distribution. We may be able to identify the flow path immediately, right? So, as we're making entry, we want to continue to use this when we hit new rooms, right? Not everyone's able to use the seat camera. You can. It can give you a rough idea as you move forward. Your eyes can give you a lot too. But as we're going to each room, it is a good idea to do a quick scan. The guy talks about it. Wall to wall, hit the ceiling over you. That ceiling over you tells you where that exhaust flow is going. Is it rolling over you? How hot is it above you? Because the last thing the world would want is for that smoke and all the crap in it to ignite over our heads, right? That would not be great. So, during suppression, which one would you prefer? The handheld, like the 6000, the attached, like those Seeks, or the Scott mask? Everyone's different, right? You can get tunnel vision. You can get dependent on this. So, the handheld may be better in most applications because it has a better resolution, better capability, larger picture, and it's kind of our go-to. We're used to it. We attach it to our air packs if it has attachment points, and it's always in the same spot. It's also very large and cumbersome, and it takes away one hand. You have to hold it with one to use it, right? It also can bump into things. Modes can be switched. It's heavier, which does tax you over time, and it can get in the way of some of the things you're trying to do. The Seek, on the other hand, it's got a lower thermal rating. It may fail faster, but it's smaller, lighter. It does have a low resolution, but you can easily just set it down, forget about it. It's not going to get in the way of most hose lines when you're moving it around, where the large one can. It's not going to bump around, but it can get torn off. That lanyard gets burned through. We've seen that repeatedly. It happens. And you may not even notice it happen. So you might have burned through it, torn it off, and kept on moving, and it's 35 feet behind you in another room. Ideally, again, that Seek is a redundant or backup device for firefighter safety. It's a situational awareness one, and it's used for survival. The best one will be to use the large handheld Seek. As we kind of identified through this class and also through discussions at the break, the sight mask, not very common. We just typically haven't used it. Gotta think that as with most things, they're gonna continue to progress the development of that. Like I mentioned earlier, there's now a flip down option that's being pushed out. It's the first iteration, just like anything. When you buy a new car, if you buy the very first one, you're gonna run into problems, but they continue to build on them and make them to be excellent vehicles or excellent tools. So, water application can be problematic too, right? For your image render, let's make sure whatever we're using, we are comfortable with cleaning the lens and returning it. We're watching for water return. You guys have all seen this probably in the burn rooms, but when we're spraying water and we get that lens saturated, it's gonna take us a little bit of time to get that lens back to where it should be to capture the image, to get that normal baseline image. That's 5 to 15 seconds. Seconds count when we're talking about survivability and also for the destruction of the stability of the structure. So being efficient with your movement is going to be tremendous. And speaking of structural integrity, while the low sensitivity doesn't provide the greatest clarity, it can give us indicators. If we can see if it has burned through drywall, if we're now having direct flame impingement on structural supports, that will be a benefit to us because we may not see that through the actual flame and the smoke. It's pretty unlikely. But that camera, if we're moving through, may allow us to say, hey, that looks an awful lot like a stud over there. If I can see the stud, that's not good. It shouldn't be visible, unless of course you're an unfinished patient. And even then, now you know you got fire on structural support. Ventilation. All right, so ticks can aid easily in ventilation. You can rapidly locate windows when you're doing a sweep of a room or a door. Despite whatever your visibility may be, you will see it because of the refraction, right? That can also show pockets of heat. When we scan through windows, you may have actual heat transfer to the frame. So from the outside, as I'm walking around, even if you got blinds down or it's completely included with smoke, I might realize that, hey, the fire is still active right there because the window frame itself is showing 400 degrees. That's not good. It'll help us find rooms to isolate. So we're looking at VEIS, or as we're progressing, as the video said, through the structure. We can close doors behind us after we've swept them. And then when we initiate the horizontal ventilation, we'll be able to identify where it should be. We can see some of the exhaust flow with the tick, right? If it's really smoky, but we can see that all of it's pushing this way, maybe we want to keep it going that way. It's already moving. Let's get that side open. And now we can get a current on the other side and push everything out. Again, ventilation always, always, always needs to be coordinated with fire attack. They should be the ones that call for it. We never want to self-initiate. Vertical ventilation. Less likely to be utilized, but still a functional option for a tick usage. When we're looking at vertical ventilation, what do we normally take with us to the roof?
Chainsaw.
Ladder, chainsaw, what else? Hooks, axes, a bad axe, a lawless axe, a mauler, a tick.
I mean, it's on our pack. So
It's attached, but we never really cognitively say, hey, I need to make sure I grab the thermal, right? How can we use it on a roof? Because when we vent, we typically sound the roof, right? And we're guesstimating where we need to make the hole. If the fire's breached the ceiling is in the attic, that roof will probably have convection display. We'll be able to see where, hey, those tiles right there are about to start melting. I know that's where the highest concentration of heat is. Obviously, we want to go up to the highest spot near the vent, right? Across the ridge. Sure. This tick can help us identify, though, where that fire spread is. Because if we haven't gone inside, or we didn't have a visual from the outside where that fire exactly was, again, we're kind of guesstimating. The tick can help us dial in our location for where we need to cut that hole so that we're not causing further fire spread by dragging it through the attic, right? And it can show the degradation of the shingles, the structure, all those things behind it. Basically, it's a tool to help cause risk reduction. It doesn't put our members inside in as much danger. Another thing too is large homes have multiple pitches. I know my house has 4 different pitches because of just dormers and other things like that. Using the tick, once again, we can locate where it'd probably be best. We can visually assess that, but when it's dark, this could be a tool to help us, right? Flashlights are awesome. They may not see through smoke that's coming out of eaves or an open window. Oh, and one last thing on this. You mentioned hooks, right? Why do we have a hook up there?
when you cut through the roof, you can break the ceiling.
Right. How do we know if we broke it?
Well, you're just hoping by contact. But
Hopefully by contact. What if it's soft? What if it's been softened by heat and water application? you may not get a positive rebound, right?
Mhm.
You can put that thermal right on the edge of the hole, and you'll be able to see if you've created one in that barrier between it and the room below. Especially if we don't have fire involvement in the attic yet. Now we'll be able to see. Obviously, smoke return is positive identification. Yes, you create a hole, but this is just one more way that we can do that. In fact, we can see the size of it. If I say, hey, did you get a good hole in it? Yeah, I think so. Turns out there's 3 pokes from a New York hook. Yeah, there's smoke pushing through. Let's make it bigger. Make it more effective. Search applications. All right, this one's pretty easy, right? Use the camera, look for victims. What else do we need to say? Well, mode selection is important. Alex, if you were assigned to search with an MSA 6000, which mode would you use on an interior firefighting application for search?
White hot, probably.
Okay. Why?
Just in the easiest to think about, really.
Yeah, we know it. That's the most common one. We're used to it. What other ones could you use?
Whatever you want, pretty much, whatever you're confident with.
Sure.
Like a survey mode.
Survey, yeah, survey would work.
The color
Iron
mode.
bow, if you're looking for color gradient, that one functions. Survey is available on the Seek. It's not an option with the MSA, but it functions similar to the iron bow without the whole rainbow gradient. Which one would you not want to use?
Rainbow.
Rainbow, easy. Yep. What about the other one?
Maybe the black.
Black hot.
Black hot because you're gonna think like.
Yeah, it
Oh,
can
that's
be
cool because it's black.
very, very conflicting, right? Okay, so when you're viewing a room or in a fire, like a small side bedroom, do you use the TIC to do the search, or do you travel into it and conduct it yourself?
You can use the ticket first. Just scan the room and then
Why not?
make history.
If you go to a regular residential house in District 1, they're not very big, right? So, someone that's going with you, if you're off of Med 1, you may have the EMT be doing the search, you might be running the TIC, right? Is it possible that in that bedroom, the EMT could have done a hands-on search by the time you fully scanned the room?
Possible.
Little 8x8, 8x10 room? Possible. There's nothing wrong with doing an extra one though, right? So that's kind of how we determine where do we want to use the TIC exclusively, or do we just go in there real quick and hammer it out? If it's a small room, might as well go in there and knock it out, right? Visibility plays a factor. If I open a door and it's clear, do I need the TIC? Not really. I mean, we can use it. Again, it doesn't hurt, but it's not necessary. And then door deployment, right? So small rooms or big rooms. Do we leave the guy at the door? Do both people go in? Ideally, you leave the guy at the door if it's really, really small, and then you keep on moving. They're keeping an eye on conditions in the hallway. You're not really limiting or controlling the flow path, but it's also a very small room, so it shouldn't take very long. Larger rooms, you may want to enter and shut the door behind you, and then coordinate it. You can throw down a marker of some type at the door, a Halligan, so you know where to get out at if the guy doesn't have a TIC or yours fails. But then you can go in and rapidly sweep it in more detail. And again, the motion matters. Slow is smooth and smooth is fast. The technology continues to progress and the refresh rate progresses, so the image stays clear. But if you took that 5200, the black and white one, the oldest one we have, and you did a quick sweep, you're going to get a really, really grainy product. It's going to skip around, it's not going to be clear, and you're probably going to miss something. Gotta be slow and purposeful with it, right? Some of the issues we've run into, we talked about this earlier, burned in picture. That happens at transition between high sensitivity and low sensitivity, but some of our thermals just get a burn in within the first 30 seconds, and it's really hard to get past. Truck 7s is a prime example. When I was creating the slides for this class, I had to make sure I captured the image and get to it really quickly, because otherwise it's going to get a ghosted display, a burn in, so that overlay from that image, it's just stuck for whatever reason. It's part of the processing failure.
That one was doing it.
Yeah, I
There you go.
was gonna say it had like the TV or the screen and the laptop.
Yeah.
And I moved it either.
Yeah, and it may clear, it may not. It's hard to tell. Obviously, water coming back, lens occlusion, windows, mirrors, all those other things. We gotta be cognizant of those when we're conducting a search. Oops. All right, large area search. So, for a very long time now, drones and helicopters have been the gold standard, especially when they're equipped with FLIR. It is the ultimate search tool, and it's an invaluable asset for personnel on the ground conducting large area search. It can provide direction, it can provide information back to them, it can keep an eye on them. However, having your own tick is also going to be hugely beneficial. They're small and lightweight, between 1 and 2 pounds at most, right? Technology continues to advance, so they can see more and more and more. They're pretty much the same. They all seem to have a green power button, and they work pretty well, and they usually come up in white hot. So in theory, we could go somewhere in North Dakota and pick up a thermal, and within 30 seconds, be able to operate it. Interagency operation is huge, because a lot of these large area search applications, urban search and rescue in the event of a disaster, that's what we're gonna be doing, working with other agencies. They are cheaper, they're cost effective than calling out a helicopter or waiting for someone to spool up a drone that has FLIR, because those aren't cheap either. And they're usable. You can replace the batteries and keep on cruising. They reduce the manpower requirements because now we have the ability to conduct a more thorough search. So in theory, you could use a team of 3 as opposed to 5 to just sweep this area right here. And that's just random arbitrary numbers, but still, you kind of get the point. And of course, it increases the speed because now we have a better visual. So we talk about sweeping areas. When we're doing large area search, we want to make sure that we're doing a focused sweep in what we're progressing through. Gone kind of are the days where you have 100 people line up arm to arm and just walk. You can still do that, it's still functional. But now with these tools, we have the ability to deploy teams that are smaller and still cover the same ground. They're doing sweeps, slow controlled motions, back and forth. They can now be recorded and reviewed at later dates. We have the ability to zoom, which is tremendous, right? And you can conduct focused searches of rough terrain. We don't have a ton of that here. We do have some around like Jacomo. So if someone drops off in a cliff out there, because we do have small 20, 30 foot cliffs, and they're in a drainage area, it may be hard to find them, especially if they're unconscious or they're hypothermic and cold, depending on time of year. Now with this thermal, instead of having to send someone down there to search by hand, we can scan. So now we eliminate that issue. That can be valleys, ditches, creeks, if they're in water, right? And the really cool thing about these is they'll penetrate foliage. They will be able to see behind it because the humidity. Now, dense foliage will create a barrier, right? But that initial layer on the outside of a wood line, this will be able to see past it to an extent. You're gonna have displays of heat show up between the leaves, and that will give us an idea of what's behind it. So you can scan it and determine where you need to progress into that area. Radiant heat also illuminates around the ambient temperatures, so it'll show up behind those. Again, they're small and lightweight, easy to use. Also, this would be one time where black hot may be really beneficial. Depending on ambient temperatures and light conditions, if you're in really bright sunlight, that could be a huge benefit to you, especially if you're looking down into something that's shaded or dark, even caves.
Or you're doing like a search at night too.
Yeah, absolutely.
Like, yeah, you can use a flashlight, but that way you can still see heat.
And you can use both. You can have flashlight in one hand, take in the other, and keep on moving. Take a look, keep walking, right? Urban search and rescue. We're fortunate this is not much of what we do, but it is still a possibility. So in USAR, these things are often used. Structural collapses, natural disasters, hurricanes, earthquakes, tornadoes. Tornadoes are a realistic possibility for us. You can scan debris piles. You can find survivable pockets in those debris piles. You may not be able to see that. Dust, whatever else, light distribution where it gets dark. The thermal may be identify that, hey, there is a lot of radiant temperature right there that's roughly 98 degrees in a pocket where the rest of it's 60 outside. Now you know there may be someone in there. It can also reach hard to get to zones where it's physically hard to climb up on a pile. We can now use that thermal with the zoom to get up there and scan in detail. This will reduce our manpower requirements as long as we're doing slow, deliberate scans and allow us to locate people or pets or whatever more quickly. They're also easy to maintain. Searchers wear out. Batteries can be replaced. It's a lot easier to keep everything moving. So some collapse considerations. That looks like a bad time. Does anybody remember this one? This was in Miami. When you have a large structural collapse, there are a lot of factors that go into play. Again, we don't do this very often, so we don't train on it too often, but it's easy to imagine that one, you're concerned about the building that's already collapsed. Oh God, that was a really bad button. 1 second. screens. Okay, we're back. I'll just stay over here for now, in case I do that again. So, we have the building itself, right? That would be bad if that fell on us or continued to fall. We have the debris pile. That's not safe and settled. It's gonna be shifting constantly. Victims are gonna probably be covered in quite a bit of debris. So that will limit their heat signature. Think about it. We emit heat at 98 degrees, give or take, right? If we have dust and water and mud caked on us, that is definitively muted now. Thermals will help us create a picture in pockets that we can potentially see. It's especially helpful when the ambient temperature differentiates between those two. It's really hot, really cold, much easier to see. It'll help us see through layered obstructions, right? It'd be pretty hard to see into that hole over there on the left, but a thermal shines right in, no factor. And it can also show us when there's concealed fires, because when these things happen, gas lines break, things get compressed, fires can start. It's really hard to see a smoldering fire in here until smoke starts pushing out. And by then, you're gonna be hustling to figure out where it is and how to get water to it. So looking at this picture, what are our concerns? There's a lot of them, right? We have a collapse. It appears to be an apartment building. Units are on scene, but there's water flowing. Could there be someone in that pile? Yeah, absolutely. Probably couldn't see him. We're racing against the clock because they're filling that area with water. Hopefully it drains out. Light seems to be either falling or gaining. Kind of hard to tell, but if it's getting dark, now we're going to be really dependent on external lighting and thermals. And that's going to take a lot of people to comb through that, right? We want to get as many of those things as we can on scene. Where do we want to deploy that tick?
From above?
From above, every person as they're progressing through. We have a drone that has the thermal imaging abilities. We want to utilize that too. What other resources could be called in?
Search dogs.
Dogs, yep. Drones, like I mentioned. Other agencies with more thermals to get through. All right. Some of the problems we encounter with thermals. Not being allowed to warm up, right? If we haven't turned it on in, a couple of days, even 12 hours, it may take a moment. We saw that with the burn-in image. Once it kicks up, we need to give it time to warm up before we really enter the hot environment. So it's one more thing to do on our way to the door. The clicking, the shuttering sound, screen freeze can be problematic, and it's normal during that period when it's firing up, right? They're not designed to sit in hot environments. They will begin to fail. 600 degrees is what those things are rated to, really 5. Above that, they have a failure point. So it's kind of like we have a time-weighted average for exposure limits on ourselves. The cameras can only be in a hot environment so long before the plastics fail. Cleaning stuff. Do we in the fire service have a problem with stuff being kept clean?
Yep.
Yeah. And then not understanding that the absence of color doesn't equate to the absence of heat. Not understanding the gradients, especially when you have 6 different color palettes. Did you guys know about all 6 of those?
6 of what?
The color palettes on the 6000, the MSA 6000?
Yeah.
You knew about all 6?
Oh, I'm sorry, no, not before you talked.
Before this class? What, would you have been able to figure it out eventually? Possibly? Possibly not, right? So, understand the tool we have, its limitations and capabilities, and then which different modes can be used for what. What problems that we haven't talked about have you guys seen with these thermals?
Being left on.
Left on, yeah,
Charging docks on 5200s don't work, you get new ones.
correct. We have cameras that don't turn on because their batteries are dead. That can be problematic. Component failures that don't get reported, that can be problematic too. So let's talk about maintenance while we're on the subject. Keeping stuff clean is not just good manners, it's vital to functionality. NFPA 1408 8.2.2 states that the participant shall clean the outside of the thermal imager after each use with mild soap or detergent and a use of a soft cloth that's clean and soapy, right? Manufacturer recommended detergent, we've heard it since fire one. Do we always do that? No. Knock the dust off, maybe a little bit of insulation off the end, put it back in and keep on going. The hose is gonna take longer to clean and we still got gear to wash. We should be more diligent about this. So who cleans the tick on a fire? After fire. The first person that gets to it. It takes less than 5 minutes and we really ought to do better with it. Having a clean, functioning thermal imaging camera can have a huge impact in making sure that we go home safely. If we go into the fire with a dirty tick, as you saw in the video we watched a little bit ago, it's not going to display properly. Are we knowingly putting ourselves in more danger? Kind of, right? We still have our eyes and ears and our every other sense, but when we're given something that can improve our efficiency and safety, we should utilize it whenever possible. What else should we check? What do you think, Alex? There's a list here. The whole thing, right? Doesn't need to be every day, obviously. If you work at a slow house or you want to get some extra credit in, nothing wrong with that. But we should be at least doing it weekly on this. I know it's not on our list, we have plenty of other things to do, but if this is going into a fire with us, it should probably be in good working order. So we can check our screws, the seams around the whole device, lanyards, the mount, is it working properly? The screen integrity, is it cracked, scratched, burned? Is there moisture underneath it? Is the battery holding a charge, or does it die when I turn it on within 2 minutes, like 5200 does? Has the battery been rotated, or is this the exact same one that's been in there for the last year? I don't know, maybe. What about the charging dock? Does it charge? Are the contacts clean? We had a problem where they weren't for a number of trucks and they were written up. Turns out, you just gotta clean the junk off of it. Does that charging station have power? If we shove a mark bag or a life pack in and knock the plug out, has the wire frayed or failed? Is the retention device, that little piece at the back there that says MSA, that holds it in place, is that functional? Is the device horizontally mounted or vertically mounted? That plays a factor in it, and whether it'll charge and how long that component will stand before needing replacement or care. Alright, it's broken, must have been B-shipped, right? What do we do when we find a damaged tick? Well, ownership is key. You have an hour in the morning to find broken stuff. After that, it's you that did it, right? You missed it, so you did it. The tick is a vital piece of equipment, and it cannot be ignored if it is broken, right? You can't just say, oh, I'll get to it later. We gotta go sweep the floors and get breakfast. No, this is pretty important. So if you find it in the morning check, no big deal. That means last shift did it. But if you miss it, it's all on you. Chief McCall referenced that all day. By 9 o'clock, you own it. If you do break it, or if you do find it broken, write it up. Ownership is key. So Donnie said this. Which write-up do we do? There is a list that has been sent and is printed out at every station that tells you where the thermal lies. Does anybody know how we write up thermals? What box we check? Whether it's building, radio, technology, tools, hose, air packs.
I'm torn between tools and technology. Or other.
Well,
Depends on the.
there is a little tiny piece here that you can't see under air packs. We write up our Seek thermals under air packs. You know why?
Anything attached to it gets wrote up with it.
Correct. The actual tick itself falls under tools. Technology would apply to the MDTs, iPads, things like that. However, if you miss it, it can also go under other. So, let's do a write-up. Alex, you're very seasoned in these. Does this look familiar? Fantastic. To do a write-up on a thermal imaging camera, we go to the Sum It Up. That was our former intranet, right? And we scroll down under the Fire page. If you can't remember how to get to that, you go to the top right corner where it says Teams and select Fire. Scroll down, on the right-hand side, halfway down, you will see the write-up section for miscellaneous repair requests. Once you open that form, this is what it looks like. We populate all the necessary information, selecting air pack because the Seek, once again, has a burned out lanyard. And then you put your description. Location of the item, if it's still operational, still in the truck. If it's broken, captain's desk. Simple enough. That's pretty much it. So, summary of what we did today. We went over, and you might have missed some of this. Objective 1, identifying all the in-service thermal imaging cameras and their components. We have the Scott site, we have the Seek Fire Pro 100, We have the MSA 5200, we have the MSA 6000 Plus, and we have discussed at length the Seek Attack Pro that is in beta test and acquisitions process. We've also differentiated the capabilities of these in-service thermal imaging cameras, thoroughly discussed the capabilities of them. We've discussed the mode options and selection of those different modes. We learned about emissivity and the limitations of thermal imaging cameras. We talked about which thermal imaging camera should be a primary versus which should be a backup, or situational awareness versus decision making. And we discussed tunnel vision, the issues that surround it and how we can avoid it. We've discussed fire behavior, determining it, and describing fire dynamics using a thermal imaging camera. We reviewed the fire behavior itself. We talked about the fire tetrahedron now, no longer a triangle. We reviewed fire dynamics. We discussed flow paths and the tip application to identify and isolate those flow paths. We also reviewed the proper use of a thermal imaging camera in the ideal age environment through suppression applications, search applications, and ventilation. We discussed how to demonstrate understanding of thermal imaging camera usage during fireground and emergency scenarios. We reviewed the use of a TIC during a 360 or size up in survey mode. We reviewed the use of a thermal imaging camera during search and rescue assignments. We reviewed the use of a thermal imaging camera during suppression activities and also during overhaul. And finally, we demonstrated our understanding of thermal imaging camera usage during large area search operations by reviewing it and discussing it as a group. We reviewed scanning methods, mode selections, discussed terrain features, limitations, and limitations of the screen on a thermal imaging camera, as well as how to identify victims. So, now we're going to transition to the practical application portion of this course. We're going to go through a series of drills. There are 5 different drills that will be conducted to display competency and capability in the use and application of thermal imaging cameras in emergency scenarios. Each student will complete all 5 drills. There will be a walkthrough at each station at the beginning. The drills will be conducted outside of this classroom. Bug gear is required for those that are described as such. Objective 1, identification. We talked about the objective, now we're going to talk about the drill. Given the compilation of different TICs available today, the student will identify the different manufacturers and models of the thermal imaging camera. The student will then identify the different components, including the lens, the display, the power button, the charging port and or battery compartment, the handle, and the retention device if applicable. Drill number 2, the student, towards objective 2, given 3 thermal imaging cameras, shall correctly identify these cameras' capabilities, including mode types, sensitivity, availability, and preferred application. Drill number 3 for fire dynamics. Students shall demonstrate the ability to isolate the seat of the fire, the thermal layer, the exhaust flow, and radiant heat when displayed on screen. Drill number 4, fireground operations. The student, given 3 thermal imaging cameras, must be able to proficiently utilize them in patterns of search and survey and fire behavior / location. The student will conduct a survey of the structure, a search of an occupied space in that structure, and the location of the fire. And drill number 5, large area search. The student shall demonstrate proficiency in sweeping, organization and recognition of thermal differentiators, and large area search. Questions? Comments? Concerns? All right. We're excited if anyone cares to reference. And for understanding, the video that we watched that was a little bit longer, where they actually went through and used that and had the cool images, that comes from Insight Fire Training. Insight Fire Training is a group of instructors that travel around the country. They recently went to FDIC and hosted a very well-attended course. They go through everything thermal imaging camera. That guy has a number of different hour to 2 hour webinars available. They are pretty interesting and they are free on YouTube. Insight Fire Training. It is 4:52. Let's take 8 minutes to meet out in the bay and we'll get all these drills knocked out.